us and please take the charge of this session.
Yeah, thank you, sir. Am I audible?
Yes, you are audible, Tejas.
Yeah. Good evening, everyone. So today it is my honor, or it is my pleasure to introduce our distinguished resource person, Professor Dr. Sachin Mandavgane, sir. Dr. Sachin Mandavgane is a professor and former head of the Department of Chemical Engineering at Visvesvaraya National Institute of Technology, Nagpur. He obtained his BTech and PhD from Lakshminarayan Institute of Technology, that is LIT. In uh, Then Dr. Sachin is also a chairman board of governance at Government College of Engineering, Amravati. He is academic council member of Batu Lonere and SGGSIET Nanded. He was governor's nominee to Maharashtra's Open University YCMOU Nasik. His research specialization is in biomass and waste valorization, biorefinery, sustainable engineering, and scientific validation of traditional sciences. He is the author of around 130 publications with more than 4,800 citations. He has produced 12 PhDs and has 12 patents in his name. As per AD Scientific Ranking 2024, that is declared by Stanford University, USA, Professor Mandavane appeared in the top 3% scientists in the world. He has handled R&D projects worth rupees 5.5 crore that are funded by agencies and 2 crore that are funded by various industries. Recently, DST has also awarded him a Center of Excellence on Agri-Waste Utilization worth 12 crore. He is also a coordinator of Marino Innovation Center at VNIT. He designed and commissioned a potato peel biorefinery plant, which is the first of its kind globally. His process of on-farm paddy straw digestion to manure has successfully commercialized, and he offers consultancy to industries to perform life cycle assessment. Today, Professor Mandavane will be sharing his expertise in waste valorization with a talk on upcycling of agri-waste, a few case studies. We are indeed fortunate to have him with us, and we look forward to an engaging and enlightening session. Please join me in welcoming Professor Sachin Mandavgane. Sir, you can proceed. Over to you.
Thank you. Thank you for this invitation and introduction. I'm thankful to the organizers of this FDP, Department of Microbiology and Biotechnology of R.C. Patel Arts, Commerce and Science College, Shirpur. And thanks to Sandeep Patil sir, who pursued and invited me, given this opportunity to share what exactly we are doing here at VNIT. And thanks to Ravindra Patil sir and nice introduction by Tejas Chaudhary. I will start. I know attending evening session at 6 o'clock is really tiring. We'll keep session as light as possible. More of information about exactly we are doing, what is possible at your end as well, right? And I I had presentation. Before my main presentation, I would like to have small introduction about the topic, because uh, I prepare my PPT, but then I realized that I should give a little bit of background about the work and the motivation behind that. Now we know that government of India has launched this biotechnology for economy, environment, and employment. Bio E3 policy. And under Bio E3 policy, there are lot many interesting webinars. I would strongly recommend participants, because I came to know that most of the participants are from life sciences background, biotechnology, microbiology, biochemistry, and related to bio mostly. Of course, others are also there. So this Bio E3 policy, and India is the first country to have a dedicated policy where bio-based economy will flourish in days to come, decades to come. Now, let us try to understand what is going to happen, what's the major shift. As of now, the fundamental needs of the society, that is energy, organic chemicals, and polymers, these are served by crude oil based refineries, to which we call it as petroleum refineries. And this is something that you and me require for our daily life. We require electricity, we require thermal form of energy, we require fuel for transportation. We cannot imagine life without organic chemical in some or the other form, and the polymers. At this moment, more than 80% of energy and 90% of organic chemicals come from the crude oil. So the idea behind this bio-based economy or bio E3 is have a shift from fossil fuel to bio-based raw materials, keeping the needs same. So can I have organic chemicals? Can I have transportation fuel or energy? Can I have polymers, which are absolute fundamental needs, which are served by petroleum refineries, by bio-based raw materials? Why we need to move away from a petroleum refinery? Reason is we import crude. We are largely depending on outside countries to meet our basic requirements. Second thing is that all these fossil fuels use GHG emission. On the other side, on the contrary, we have bio-based raw materials which are carbon neutral in nature, and that can provide additional revenue, additional source of money to the farmers. So this uh, gives birth to the concept called biorefinery. So biorefinery is analogous to petroleum refinery. So what we do in case of a petroleum refinery is we start with the crude oil, and from crude oil we make arrays of products like gasoline, diesel, kerosene, tar, and platform chemicals. We are going to talk about platform chemicals in the next slide, and polymers. While in case of a biorefinery, instead of a crude oil as my starting material or a feedstock, I have bio feedstock. And from bio feedstock, I make arrays of products like biochemicals, biofuel, and some specialty products. See, in case of petroleum refinery, what we do is we take crude oil, and from the crude oil, we get different fractions of extremely low molecular weight to high molecular weight. And when we get this fraction, each fraction with a different molecular weight has different molecular structure, different utility. Similarly, here in case of a biorefinery, we want to go for sequential extraction of valuable products. Generally, till now, what we have found that biomass is used for generally single product. But instead of having a single product, having multiple products in a sequential way is something that makes the concept of biorefinery economically viable. There is no issue in technical viability that has been proved. The issue all is about the economical viability. We are having ample of grasses, different types of grasses. There is a ICR lab here at Jhansi. They work only on grasses. Then we have agricultural residue. I'm going to talk about agricultural residue. Two types of agricultural residue. One is maybe stalk and straw kind of thing. We have grains, right? And each grain almost produced or more than that straws and stack. For example, if I go with paddy straw, 1 kg of paddy straw produce almost same amount of one kg of paddy, one paddy grain, the rice produce almost same amount of paddy straw. If we go for pulses, cereals, the ratio may change, but on an average, 1 kg of grain produces almost same amount of agricultural residue. If you come at horticulture waste, like vegetable, fruits, flowers, right? There are 30 to 40% waste. And from fruits, again, we have seeds. That is another waste. I'm talking only about agriculture waste. If we go to seafood, that's a different ball game. The kind of waste which is generated from animals, slaughterhouse, or maybe from fisheries, that's a different thing. But we are focusing only on bio, that too from agriculture. So the approach reduces, the biorefinery approach reduces the carbon footprint and thus the environmental impact. Now let us try to find out the classification of biomass, the general classification. We have energy crops. Energy crops like grasses, bamboos, sweet sorghum, right? So these are typically energy crops. Then energy crop means they are traditionally being used for drawing some kind of energy. As when it comes to energy from a biomass, we have two routes. One route is anaerobic route, and the second route is thermal route, like pyrolysis, gasification. Right? Then we have agricultural residue, stalk, leaves, husk, something that I was talking about. Then the forestry waste. And the fourth one is industrial waste. So we will be talking about the industrial waste and agricultural waste as a part of the research that we are carrying out here. Further, when it comes to constitution point of view, the biomass can be further categorized into triglyceride based feedstock, where we have vegetable oil, animal fat, something like that. Then sugar and starchy feedstock, right? And then we have a lignocellulosic feedstock. This is based on the composition, the constituents of biomass. Now, as far as petroleum refinery is concerned, we have seen that petroleum refinery meets our needs like energy, organic chemicals, polymers, right? Now, the main products of a petroleum refinery are following. It's a syngas. Syngas is carbon monoxide, hydrogen, methane, combination of that. Then olefins. So these are unsaturated hydrocarbons. Ethylene, propylene, butadiene. Then we have aromatics like benzene, toluene, xylene. So when we see that we have this IOCL, HPCL, and each of you go and fill petrol at some of the other petrol pump. They are either owned by HPCL, IOCL, BPCL, Reliance Petroleum, right? So these are the petroleum refineries. These petroleum refinery mainly produce these three products, and they are called as building block chemicals. Based on using these building block chemicals, the three main requirements: energy, organic chemical, and a third one is polymers. So we have ethylene joined together, polyethylene, right? So these are called as building block chemicals. Now, the challenge when we want to shift from crude oil to biomass, we need to produce similar building block chemicals even from biosource. And these are, there are almost 13, sometimes somewhere you will see 17 bio-based platform chemicals, 13 platform chemicals. So these are the platform chemicals which are produced from bio-based, and then again from this different required chemicals are produced which are required for the society. So this is the background which I thought that I should give to you, and now I will move to presentation. Presentation means a couple of case studies which I wanted to share with you. Yeah. So this is the work, the introduction part, the earlier part that I shared with you, with the intention that now there is a growing awareness that we need to teach students about this concept of biorefinery. We need to teach students how the so-called waste can be put to use. We need to tell students about GHG emission, carbon footprint. If I compare crude oil based products with the bio based product, so for example, if I take a case of ethanol, all of you know that now government has allowed up to 10% blending of ethanol in fuel, right? Now this ethanol I can produce from the crude oil, the fossil fuel route, and I can produce it from the bio-based fermentation route. Almost every distillery and sugar industry is now having ethanol production because this ethanol production has a market. So I now there are a couple of products which are available, produced by both the routes, the conventional fossil fuel route as well as the biological route. So we need to tell students about new feedstocks. I still remember that in 2016, mostly 2016, every December, uh, ACS, American Chemical Society, publishes one perspective article, and it gives the perspective for next year, next couple of years, or a decade. And the perspective article was all talking about the new sources of carbon and hydrogen. The present source of carbon and hydrogen is crude oil. We are looking at bio as a next source of carbon and hydrogen, right? And can I make almost everything which is possible from fossil fuel, from crude oil by bio-based raw material? That's the concept. And this is something that maybe we need to teach students so that they will be more equipped with the next new generation jobs and the market. Let us come back to the research work that we are engaged here at VNIT for last 10 years. Now, we are focusing mainly on small and marginal farmers. Around 86% of land holding in India is with the marginal farmers. The, the, the textbook definition of marginal farmer is the one who holds 2 hectares of land. So 1 hectare is approximately 2.5 acres. So below 5 acres are small and marginal farmers. India produces around 500 million metric ton of agricultural residue annually. This is the number which I have taken only from Punjab because this number is uh, available in public domain with respect to Punjab. And if you look at the, as I told you, that 1 kg of grain produces almost same amount of agricultural residue or little more than that. We know how much of the food production this country has. So that can tell you, if we can just extrapolate, we can find out how much is the agricultural residue which is produced in the country. And 30%, when I was moving around in Nagpur, I'm from Nagpur, so you know that Nagpur is known for oranges. So when we were discussing with orange farmers, they were telling that the falling and the agriculture, the horticulture waste or the orange waste specifically is around 40 to 50%. One farmer, when we had a small meeting with the farmers, they were telling that to one plant of orange, around 800 uh, fruits at the very beginning. They have 800 bearing of 800 fruits, right? But when it comes to harvesting, that number is somewhere between 200 to 300. Of course, this number may vary, but it is somewhere in this range only. Because of untimely rain, because of bad weather sometime, poor transportation sometime, lack of sufficient cold storage. So there are many reasons for that. So what exactly we do? This is the scheme that we do here at BNIT, and for which DST has granted us a Center of Excellence. We start with a biomass. We do lab work. And when we do lab study, we found that there are three potential products. One is related to agriculture, maybe some form of agricultural input. Then second is animal feed and fodder, fodder for cattle, feed for small animals.
Excuse me,
And
sir.
yeah,
Sir, your screen is not visible.
hey, is it?
Yes, it's not visible.
No, it's
Correct.
visible, ma'am. We could see his screen. Maybe there is
Yes.
some problem at your end.
Yes, everyone is seeing, sir.
No, sir. I'm not able to see. I am also not able to
No,
see.
sir, slides are not visible.
I thought
Actually,
it
And
was
not
not
also
being shared.
screen is not visible, sir.
Sir, have you shared this slide?
I will share once again. I will share once again. No, doesn't matter. I will share once again.
No, sir, it's not visible.
Hey, now
No, sir, not.
Yes,
Yeah,
now,
yes,
now.
sir.
Visible now.
It is visible.
Now,
Yes,
sir,
Yes,
it is
now it's
visible.
visible.
but then my last 10-15 minutes, were they without slides?
But it's
Yes,
okay,
sir.
sir. You're
Now it is seen.
you're saying so much good
Yes,
that we
sir.
are getting each and everything.
Yes, informative lecture, sir, no problem.
But I made PPT. I put time
I-
for that. You should have informed earlier, madam.
Oh,
Anyway,
I just thought it is not being shared right now. Okay.
now, madam, now is it visible?
Yes, yes,
Yes, yes, sir. It's
It is
very clear.
clearly visible.
Yes, sir, it's
Yes,
visible
yes.
now.
Okay, fine. Okay. Should I show my earlier slides then? But anyway, I spoke about that. If
Yes,
you
sir.
want, I can see. I'm extremely sorry. I mean, could you see these slides now?
Yes, yes.
Platform chemicals and all those things?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Yes.
Yes, sir. Yes, sir.
Oh my God.
Now it's seen.
So I would request that at least you should know biomass is triglyceride, sugar, lignocellulosic, building blocks of petroleum refinery like syngas, olefins, aromatics, right? And these are 13 platform chemicals. Now I will come back to this one. Hope you are able to see now. General scheme of work.
Yes, sir, it is
Yes,
clearly
sir.
visible.
Yes, sir.
Yeah. Okay. Now see how it goes. We start with biomass, then work in the laboratory. So we call it as TRL3, TRL4, right? Or sometime up to TRL5 as well. What I mean to say is that if we are doing something in beaker conical flask, we extrapolate it into drum, maybe 50 kg drum or 100 kg drum or 200 kg. And then we go for some kind of trials, right? And we are fortunate to have very good industrial partnership. And I'm going to share the help the industry is extended to us. So the product that I'm going to talk to you are basically related to agriculture, veterinary, and food supplements. And of course, now it is almost compulsory, mandatory to do carbon footprint, life cycle assessment, techno-economic analysis. So that we do. So, for example, if we start with the paddy straw, again, paddy straw, we will do analysis, characterization, find out application in lab, then go to agriculture, find out whether it is useful on a scale up, actual field, whether it is giving results, then do techno-economic analysis, find out whether it is feasible, find out what is its carbon footprint, and either through startup, take it to the society or the industry takes it. This is the general schematic of the work which I'm going to talk to you. Yeah. So here we'll start with fruits and vegetables. So in fruits and vegetables, this is the approach. The approach is, can you see the my cursor? I think no. Now cursor is
No,
visible,
sir.
right? Now you can see cursor.
No, sir, your cursor. Yes, sir. Your cursor is visible now.
But then
Visible.
I am not in the presentation mode.
Yeah,
Anyway,
but your cursor is visible and the slide is visible too.
then that's fine. That's
Yeah.
fine. So see, we start from here. We have fruit and vegetable green waste, maybe from industry, maybe from farm. I'm going to share both these case studies. So we do pre-processing. So what is pre-processing? The first and the foremost part of the pre-processing is one, cleaning, if it is from the farm itself. But if it is from food industry, we need not to clean it, right? And size reduction. We need to have size reduction. Once we get size reduction, then we found the nature has gifted every fruit with a unique biochemical. Potato, we work on potato, we work on pomegranate, apple, onion, tomatoes, oranges. So each of this fruit, vegetable, it is bestowed with a unique bioactive molecule. So we have developed, so uh, my collaborator from chemistry department, she works on selective separation of bioactive molecules. So this is what we do. We extract bioactive molecules, then that bioactive molecule is either encapsulated or it is converted into some kind of tablet or a powder which is used as a nutraceutical or functional food. These nutraceutical and functional food then further go for some trials. We have collaborators in veterinary university, animal nutrition department. There we try this thing. Now, once the bioactive molecule is extracted, we are left with the fibers, mostly insoluble dietary fibers. These insoluble dietary fibers finds its way again in some kind of poultry feed or a pet food, somewhere like that. Now, this is about the peel part of it. When it comes to, of course, it all, this is not a generalized one, I'm just telling you the scheme of it. If, for example, if I take oranges, the peel part will follow the upward route. If I take the, say for example, potato skin has bioactive molecule, it has dietary fibers we already use in poultry feed, but the starchy part, we send it to fermentation. And in fermentation, obviously we will get bioenergy, right? And the leftover slurry can be used in a compost. We can even get enzymes. So I'm telling you the arrays of different products which are possible. And enzymes, let it be compost, then we go for field trials. I will now move to the next slide to understand it properly. So this is a potato biorefinery, which is a DST funded project, and Merino Industry is the industrial partner. Merino is at Hapur. Hapur is 65 kilometers from Delhi, near to Ghaziabad. And this belt, West UP belt, is all about aloo. Meerut, Ghaziabad, and Hapur, they are all potato growing area. So this industry is in potato processing. The product is potato flex. So what they do is, one potato, the first stage is washing potato. Once the potatoes are washed, it is peeled. So the peeling is done by two ways. One is mechanical abrasion, the way we do at home, or steam peeling. In case of a steam peeling, potatoes are exposed to high pressure steam momentarily, and only the skin part get loosened, and then that potato is passed through brushes. So it brush out the peel, and the starch goes for processing. Our starting point for this particular biorefinery is the waste which is generated in the peeling unit, because it has peel and little bit of starch adhere to that. So that's the starting point. The industry otherwise was either landfilling it or somehow disposing it, but not extracting any valuable products. And that's the reason the title of today's talk is upcycling. So from the West, we are producing something which is of a higher value, right? And the products that those were extracted are nutraceuticals, dietary fibers. Dietary fiber itself was used as prebiotic, biogas. The starchy part was used as a biogas, and finally compost. I'll show the video. Let me know the video is visible. No,
No, sir, it is not.
no. Even it is not visible to me. Wait. I'm for the moment I'm stopping the presentation. I will get YouTube video for this.
Yeah, totally fine, sir.
Sandeep sir, you please search on YouTube potato biorefinery.
So should we share the video by our?
Yeah, you please put it on the chat box. I
Okay.
somehow my YouTube is not opening. Wait, I will try from another.
Sir, actually,
Wait. I am able to do it. I will stop my video, I think. Internet is slow.
sir, you can shift the tab.
No, what happened? I have to use two different operating systems. That's the issue. Potato biorefinery.
What is the problem, Tejas?
Actually, sir is unable to share the video.
Okay.
Uh,
Now I'm able
and
to.
in the starting of the session, we have already closed the chat box, so we are unable to share the link of that video.
Fine. No issue. Then wait.
Sir, we could hear the music, but not the video.
No. I still have to share the. I will share the screen. Wait.
Okay, no problem.
Now I will share the screen. Whether it is visible?
Yes, sir, it is visible.
Yes, sir, it is visible. It is visible.
This is the pilot plant at Hapur. Now see, I will just show you what happens. This is the tank, the first reactor in which hydrolysis takes place, and we separate the starchy material, which is adhered to the pill, and these two are separated. So this is the pill, and this is the starchy part, and this starchy part goes to biogas. Then the pills are dried in a spray dryer, sorry, tray dryer. So the brand of Merino is Veggie. So we started doing it in a lab in a small scale. Right? So then this is old video 2019. Then we extended our work to oranges, apple, pomegranate. Few of these things I'm going to show you. Fine. I will come back to hey, I should have clicked twice. Anyway, I'll move next. So what we did is there are two parts. One part is the technology, and I know that couple of faculties here are from science background. I will tell you the science part of it. The technology part was equipment design, bigger reactors, and all those things. But then Dr. Anupama Kumar, she is from chemistry. So what we did is potato peel has polyphenols. We developed different methods of we tried different solvent for extraction. One, then we tried different methods of selective separation of bioactive molecules, these antioxidants. We found that MIP, molecular integrated polymers, is relatively convenient method for extracting it, and that is one. Second thing that we tried is microencapsulation. And for microencapsulation, we made use of spray drying. So, so we tried different ways of extraction. We tried different ways of preserving polyphenols, antioxidants, right? And that is what we did from typically the science part of it. Then when it comes to interdisciplinary work, I strongly, I'm fortunate to have good collaborators outside my institute. For example, the potato dietary fiber powder, which we have seen, something that we have taken out from the trade dryer, then it was pulverized, and then we gave it we did at VNIT, we did detailed in vitro study, the characterization of peels. Then we gave it to our collaborator. They work with chickens, broiler, and to broiler they feed it. And this paper is available online. The surprising part was just 250 grams. I repeat, 250 gram per ton of broiler feed was the most optimized one. It improved, and most importantly, it avoided use of any antibiotics. Increase the bird, they call chicken as bird, increase bird weight comparatively by 200 grams, right? So those are a couple of benefits which could be derived. Fine, this is what I was talking about. Biogas, then we work on biogas, biofertilizers, how exactly we can enrich biogas. Then another thing that we did is, as I told you, West UP is a part of NCR. NCR is National Capital Region. It's extremely sensitive from pollution point of view. So the farmer in one season grows potato, another season paddy. So they have a lot of paddy straw. So we have co-digestion of paddy straw with this potato waste. And we could achieve three things. We could have higher biogas, we can have a faster biogas. Higher biogas means overall they call it as biomethane potential was higher of this combination, HRT was reduced, and methane content was more than 65%. And this is all at scale. I'm not talking anything about the lab level. Of course, we started with lab, and it's like a baton. We started with lab, we reached to lab plus, where we did it in drums, something which I showed you, and then we took it to industrial scale. Now, the second case study is about oranges. Very dear to me. Meanwhile, when you are watching these videos and listening to presentation, I have a request to you. And anyway, I have to give 5 questions to you as well. So why not to do it right now? Please list down the different fruit waste, vegetable waste, agricultural waste that you have encountered, you have seen. Maybe, for example, I will tell you. Last year, one fellow came from Palghar. Palghar is near to Mumbai, and so it's on the border of Mumbai to Gujarat. So this Palghar district. So farmer didn't come, but one fellow approached to me. He works for FPOs. FPO stands for Farmer Producing Organization. So they are in the business of growing sapota. Sapota means chiku, right? So they said that we grow sapota, and a lot of seeds go waste because they are in sapota processing as well. So they grow sapota, they slice it, then they sun dry it. The dried one is then packed. Maybe they are converted into kind of flex, maybe powder, something like that, right? But so their entire business model is based on support of fruit. Somebody told them that we at BNIT work on agricultural waste and fruit waste. So they approach us, and they wanted to make use of these sapota seeds. So we did study, and we now started working. We found that sapota seed is an excellent feed additive, right? Work is going on. So I want your suggestion that what are all the possible things which we feel. See the objective is, can we create some value from the waste? Can we have circularity and the farmer get some additional revenue, right? And all these things are very, very unique to India. For example, Nagpur oranges. Nagpur oranges has a GI tag. GI tag means geographical indicator. It's specific to a geography, specific to location, right? Those who are from Maharashtra, they might be knowing that the grapes in Nasik, right? So you have product's name and the location, or all of us know Darjeeling tea, right? So these are the words which come together. That's unique because of the geography, because of the uh, climatic condition, weather and soil and all those things. Now Nagpur oranges, so this word Nagpur orange has GI tag, right? And the reason for GI tag is its unique flavor and its unique taste, right? It's unlike Kinu. So Nagpur oranges are totally different. If you have never tested, come to Nagpur in the month of February. I will have feast with you, right? And now these oranges, as I was telling you, some statistics, 30 to 40% goes waste. They go waste on farm. They go waste in the mandi, APMC as well. The mandi, the big mandi in all big cities. We have here big mandi, right? We call it as a santra market. The oranges go waste. So there was a call from DST for solving regional problem. So we proposed this thing, that creating value from oranges. So this is the outcome. Let's watch it. So we have these oranges sorted. They are typically waste oranges. So we remove juice, and these are not edible oranges. Peel is removed. Then we take out oil extraction. We get essential oil. And the leftover, if at all any, goes for composting. So these are small teams, the meetings that we had with farmers. And these are the different products. Interestingly, just a moment. I was here. Right? Essential oil, fermented juice. Fermented juice is useful in Eastern countries like Indonesia, Malaysia, even Japan. They use fermented juice as a liquid fertilizer. Then we have orange peel powder. Orange peel powder is used in cosmetics. It has multiple application. Orange tea, right? Just like we have green tea, so we have this orange peel tea. And then fifth is orange peel marmalade. This marmalade is only when the oranges are good. So we put it at the end. Our main focus was essential oil, fermented fruit juice, orange peel powder, and basically first three, because fourth and fifth are for human consumption. We are somehow we're skeptic about human consumption because we are using waste oranges. So Nitin Gadkari is Nagpur's member of parliament. He was quite interested in all these things. He visited our department for, we have small presentation there. So the project was funded by SEED division of Department of Science and Technology. It's typically region-specific problem statement was the call. Then we use this essential oil again. Broiler chicken, in broiler chicken, essential oil is used. So why not to use the Nagpur orange oil? That's what we did. Right? Again, dietary fibers. So in bakery products, citrus dietary fiber is in demand. That is what we try to do. We added it into bread, some cookies, biscuits. We tried it. Now, second part is about straw and stack. So first part, I talked about the fruits and vegetable. We looked into two case studies, potatoes and oranges. Now let us look into the straw and stacks. So we work on paddy straw. It was a funded project. So this is what we are doing. What we do, again, study the biomass, shred it, right? We develop here at VNIT a culture called Bajrang Band. Bajrang Band is a microbial consortia. It's a unique consortia which reduces the C/N ratio of straw and stack below 20 rapidly. Now, the real challenge of utilization of straw and stack is high C/N ratio. Because it has almost no nitrogen, extremely high C/N ratio, more of a carbon cellulosic material, it doesn't degrade, right? So if we want to digest it, degrade it, in other words, we want to reduce its C/N ratio. This microbial consortia reduces the C/N ratio extremely fast. Then we patented it. Then we thought that, and by this we reduce the composting time of 3 months or 4 months to 3 weeks to 4 weeks. So it's rapid composting, right? I'm going to show you video of rapid composting immediately after this. Then using solid state fermentation and the same bioculture, we have enzyme cocktail rich with cellulase xylanase. We use it for fodder pre-treatment. We found that when it is used for fodder pre-treatment in cattle, this is the work done with NDDB, National Dairy Development Board. They help us in identifying farm and carrying out the entire study because we know nothing about veterinary. And when we did it, we found that the milk yield is increased by 5%. Generally, when the milk yield 5 to 8%, when the milk yield is increased, it is at the cost of fat. Whereas here, we found that even the fat is increased by 1.8%. Then enzyme treated paddy straw, cotton straw, we use for accelerated composting. Anyway, with Bajrang Bhat consortia, the time was reduced from months to weeks, but with enzyme treatment, we further reduced weeks to days. And we found that it is extremely useful in horticulture and nursery. And I told you about biogas also, right? We'll move forward. Watch this video.
In a laudable industry academic collaborative venture, Merino, along with the Energy and Resource Institute and the Vishweshwaraya National Institute of Technology, Nagpur, has adopted a cost-effective method to convert paddy and other agro-waste into a soil-enriching compost. This is an environmentally friendly alternative to stubble burning. Large quantities of paddy straw is collected from in and around Hapur and stored in sheds. It is then reduced in size by a pulverizer. After this, the shredded and crushed paddy straws are fed into a ribbon tray, where the patented bioculture is sprayed into them and it undergoes dry digestion. Merino Innovation Center has come up with a unique culture, a biodigester, which digests paddy straw in as less as 3 weeks' time, which otherwise takes 3 months to 6 months. And the product is patented. Not only so, the product has commercialized with a title as Bajrang Band. So Bajrang Band is a very unique decomposer, microbiological consortium, which is used for rapid composting of paddy straw, which we can do as a centralized facility like what we are doing here in Merino. On a pilot level, 1 ton of paddy straw on a daily basis is being composted, is being digested, which we are now scaling up to 15 tons per day. The primary aim of the patented bioculture is to tackle this huge problem of bio-waste and its fruitful dispensation. It is aptly named as the Bajrang Band. The mixture is then collected and stored in plastic bags, which themselves act as an anaerobic digester. With the help of the microbes in the Bajrang Band, these shredded paddy straws get decomposed in 21 days and then is an organic manure for agro use. The process is simple, but the result is a remarkable alternative to a major environmental problem. Professor Sachin Mandavane tells us of the meaningful and valuable collaboration that Vishweshwaraya National Institute of Technology has with Merino Industries.
So I will skip this. This is about how enzymatic pre-treatment brings down the C/N ratio. As I told you, it does it in days, which otherwise takes some. Generally, it takes months. With the culture that we have, it is brought down to weeks, and then with enzyme solid state fermentation on farm, because we believe that the farmers himself should be able to do this thing and create some value from the agricultural residue. So this is what Merino is doing at their campus. It's a well organized work. They are producing almost 1.5 tons, 2 tons, right? And based on this, at Haryana and Punjab also, couple of units are upcoming. This is about biogas. Biogas, paddy straw. It's a co-digestion of cow dung, enzyme treated paddy straw. We call it as a paddy dung, and potato peel. Because I think I might have one slide. Oh, it's not there. So when enzyme is, we treat paddy straw with enzyme, the physicochemical properties, not the chemical, not the biological part. The physical chemical properties like COD, total volatile solid, then pH, moisture content, they are almost similar to the to cow dung, right? So cow dung and paddy dung, as we call it, we are feeding it, and we found that if cow dung is giving 4 meter cube of gas per 100 kgs, here a combination of paddy dung and cow dung is giving me 6 meter cube, 6.5 meter cubes. So more gas is produced. Yeah, this is what more gas and better gas. That is 66% methane almost. These are the trials which we conducted with the help of NDDB. These trials were conducted at Shamshadabad near Hyderabad, and we found that there is, and again, the focus is doing everything on farm, right? Instead of purchasing costly enzyme, can a farmer do it, right? So that's the main objective of entire work. And this is what happened. Milk yield increased by 5% and fat by 1.8%. You just go forward. Yeah, when the same trials were done at MAPSU, Maharashtra Animal and Fisheries University. It's a veterinary university of Maharashtra. They did it on goats, right? And there's a weight gain by 5%. Now about biomass ash and biochar. You might be coming across a lot of work on biochar these days. In typically with reference to use of agricultural waste and agricultural waste typically, and send it back to soil. So what we have found is this biomass ash is unlike whole fly ash and is a rich source of potash. So we develop a simple method of extracting potash by bio-leaching. So we call it as a biopotash, but it is from biomass ash by using microbial consortia. This is what we did. We extracted potash from, and yeah, just some information. The information is more and more industries are shifting towards use of biofuel instead of coal, in place of LDO, they call it as a light diesel oil. So instead of this fossil fuel, industries are shifting towards biomass. So once we fire biomass into a furnace or a boiler, the organic part gets sacrificed. The inorganic part appears in the ash. And this ash, when sent back to the soil, we are creating circularity. But this ash is high in pH, one, and the second thing is that its electric conductivity is very high. Moreover, it has uh, potash around, based on the biofeedstock, as minimum as 5, maximum as 11-12%. It has phosphorus and it has other micronutrient also. So we develop another microbial consortia. We call it as Angad band, and it improves, rather increases the solubility of potash and into water, and we develop different products. This paper is available in public domain. You can just go through it, because since you people are from bio based background, you will find it interesting. Yeah.
These days, chemical process industries are using biomass like paddy straw, biomass briquettes made from cotton stack, soybean stack as a source of fuel. When it is burned in furnaces and boilers, ash is produced. This ash is a rich source of potash. we can use this ash back to the soil and check its effect on the soil health and uptake of the plant. This is the idea we propose to BRNS. BRNS sanctioned this proposal. And as a part of BRNS project, we are working on use of biomass ash in soil health and plant nutrient uptake. We have collected this biomass ash from an industry near Nagpur. Butibori is the industrial area. This industry uses biomass briquette as a source of fuel, and the ash is produced 3 tons per day. Now, this ash, when we collected, we characterized it, we did detailed analysis, and we found that it's rich with potash as well. Now, if I want to make use of this in soil, I need to make granules. Making granules of this ash is a challenge because of the nature of the ash. It doesn't have binding capacity. Therefore, we were looking for some binders such that it is compatible with the biomass ash. At the same time, it adds value. Out of different binders that we tried, we come across compost. This compost is made from paddy straw. We made the compost, dried it, and then pulverized it. We tried different permutation and combinations of proportions for using biomass ash and compost. We found that 50-50 is the optimum ratio in which we can use compost and biomass ash. When these two things are properly mixed, they combine together and provide a better binding capacity. We are able to make granules using this formulation. In this formulation, we have added binders. Now, once we have this method, a process of making granules using biomass ash, we can make granules as per our requirement. Means we can fortify and enrich the granules using maybe calcium-rich granules, maybe silica-rich granules, and thus we can have granules of different composition and formulations. We can produce granules using biomass ash and compost of desired diameter. We can tailor the diameter based on the requirement. The maximum diameter that we achieve is around 6. The minimum diameter that we achieve is 2. 4 millimeter is the recommended diameter as far as FCO is concerned. When biomass ash granules are used for experimental trials in private farms, it is found that the soil health and plant nutrient uptake are improved.
Right? Fine. Couple of papers. Then this is theory, and more from engineering point of view, what we do. This is our dry lab work. We'll do life cycle assessment, techno-economic analysis, then sustainability assessment. Right? Yeah, this is the project which has been sanctioned. This is the center. This is upcoming. SWAHA stands for Sustainability Assessment, Waste Valorization, Agricultural Input, Health Supplement, and Awareness and Training. So it's an offering to Mother Earth through this Center of Excellence. Thank you. Thanks a lot. We'll stop sharing. So my request is, the one question that I'm going to ask you is, please list down the agricultural waste in and around your area. So I'm done with presentation. Thank you.
Okay, sir. Thank you. I request participants, if you have any questions or any queries regarding the session, you can raise.
Hello, sir.
Yes, madam.
I just wanted to ask one question. It was excellent presentation, and I must salute you for so much work and so much efforts that you have put in upcycling the waste that is generated, because that is a huge problem that we are facing now, and I think that is on the agenda of Government of India, that waste management, maybe it is agriculture, domestic, industrial, whatever it is, which is causing a lot of pollution and so many other issues. So first of all, salute to you for such an excellent work and presentation that you have done.
Thank you.
Just one question I wanted to ask you is about the enzymes that you have mentioned, that pre-treatment of the waste with xylanase and cellulase. So these enzymes you must be using in the crude form, right?
Yes, crude form.
So how you are sourcing it, or how is it used?
See what we are doing. I mean, I couldn't understand your question. Sourcing means?
Sourcing means you are using directly the because
We
working
are
with pure enzyme or purchasing commercial enzyme will be very costly. So are we working with the crude enzyme, like growing the organisms and using it as it is, or how it is?
Yeah, I will tell you. See, what we are doing is uh, we are typically using solid state fermentation, right? Our
Hmm.
main part is the culture, right?
Hmm.
So culture, solid to liquid ratio for solid state fermentation we required is 1:1. So for example, if I'm taking 5 kgs of paddy straw, shredded paddy straw, I'm putting almost 5 liters of culture, right? To put it
Hmm.
into solid state fermentation. For on farm
Yeah.
application, we use typically drum. The drum which is available with the farmer. Keep it airtight. It is facultative anaerobes basically,
That I
right?
understood. You have shown in the video also.
Right.
Yeah, that was
So
clear. Uh,
no, I'm coming to the point.
yeah.
Now, once maybe after growth phase is over, maybe around 14 days, 15 days, we found in
Hmm.
our case,
Mm-hmm.
based on feedstock, that number days varies. Maybe on 14, 15 days, we put
Yeah.
buffer, right? Once we
Okay.
put buffer,
Hmm.
right? For buffer also we had to optimize because the
Yeah.
cost is involved, and then we leach it out. Once we leach it out, now we have two options. One option is the leachate itself we are using in some
Hmm.
cases,
Mm-hmm.
right? It's a crude one, but
Hmm.
leachate itself is useful. It has some kind of microbial debris as well.
Yeah.
In where we required a purified form, we are centrifuging it and passing it through membrane. We have specific membrane cartridges,
Okay.
right? So where we want to do purification, but even after membrane, see, centrifuge will remove my suspended particles and debris,
Yeah.
right? Then I pass it through membrane. When I
Okay.
pass it through membrane, second level of purification take place.
Right.
But we do not separate cellulase, xylanase, and all those things. The
Mm-hmm.
end product is the crude one.
Yeah.
Have I answered
Okay.
your question or not yet?
Yeah. Yeah. And then second thing, what I understood is the farmers are also trained to do this,
Yes.
right?
We
So,
are giving training through KVKs. Yes.
yeah. So on farm, when it is produced in the large amount, because the scale will be so huge,
Yeah.
and then they are. What I understood is they are trained to use these things and
Yes.
process it on their own,
Absolutely. That is the
right?
objective. Absolutely. Absolutely correct. We are working with KVK Bhandara. We are working with KVK Ambezogai, right?
Oh,
We would be working with KVK Nandurbar. So couple of KVKs we are working because KVKs have a very strong farmers network.
yes,
But
yes.
you absolutely correct. We need to train farmers.
Yeah, because they will need maybe the quick results, or anyone will want the
I mean, this is
results in
something
less
new
time.
for them. Something
Yeah.
new for them. Though the process is extremely simple,
Hmm.
we require hardly any skilled labor. Unskilled labor can do this thing, but
Yeah.
training is required.
Yeah,
Training is
training is required. And similarly for ash also.
Madam, as farmers cannot use it
No, no,
directly.
no, not
Reason
for
is
farmers. When you are using it for mixing it with the paddy straw compost and all that. So similarly, ash also you are treating, or as it is you are mixing it with the.
No, I will tell you what we are doing is ash we have to get it from the industry.
Yeah.
Most of the process industry, if you have any sugar mill around,
Exactly,
each sugar mill use bagasse as a feedstock.
Right.
Right? Now the ash that you get is the rich source of potash. To
Right.
that we add our second culture, right? And when we
That you
add
said Angad.
Angad bud,
Yeah.
we incubate it for 5 days, 7 days, right?
Okay.
So that the leaching get accelerated.
Okay.
Right? And now that ash, generally that ash as it is can be used, but the farmers have this psyche that they want to use granules. And moreover, there is something called FCO. FCO stand for fertilizer control order. They said that if you want to make use of anything as a soil input, it has to be granules of 4 millimeter diameter. So they have given some parameters, physical parameters.
Yeah. Yes.
Otherwise, ash as it is good for use in case of a nursery soil also. There is something called nursery soil.
Okay. Oh,
Right?
so
Have I
they.
answered your question?
Yes.
Thank you.
Yes. Thank you, sir. Thank you so much.
Thank you.
Sir, I would like to know the logic behind naming your that Bajrang Ban and Angad Ban.
No. There is no logic. The logic is
Actually,
the merino industry.
is it microbial consortium or is it an enzyme cocktail?
No. Listen. I will tell you. Our industrial partner, Merino Industry, the CMD, the chairman and managing director of this industry, is a chemical engineer from IIT Delhi, 1975 batch pass out, veteran chemical engineer, and he decided that we should put all these names in mythological Ramayan's character. So there is no logic as such. Absolutely no logic. Only logic is that we wish to put that name. That's all.
Is this a microbial consortium or enzyme cocktail?
All these are microbial consortium.
Microbial consortiums. Okay.
And details you can find out. We have recently one paper published on upcycling. There you will find details of Bajrang Band, and another paper about biopotash, bio leaching from ash. That paper is also published. So detail you will get. I purposely skip the typical technical details here.
Okay. I would like to.
Sir.
Yes, Avinash sir, please.
Hello, sir. Sachin, sir, good evening.
Good evening.
Very enlightening lecture and thought-provoking lecture, especially for the microbiologist. Here, I would like to ask one question. I belong to the North Maharashtra, especially from Nasik region. We have not many dairy farms at farmers level. There's a concept of murghas at our level. What farmers or that dairy keepers used to do, they bring all these fodders from a market or from their land, especially that is made up of so many grass. They chop it, fill it in the large bags.
I know murghas very well.
In that they put some cultures, all these things, and they keep it as it is for 2 to 3 months, and after that they give it to their cows, especially Jersey cows, and they're telling that the yield of that milk is more as compared to giving in the raw type of the form. So have you worked on this? Or is there such kind of consortium developed?
Sir, this is a well-known fact. They put lactobacillus. Nothing else.
Yes. Only lactobacillus.
It's a achar. It's a animal's achar.
Yes.
That, and they don't use the entire murghas. They give 5%, 10%. It's additive. Okay. It's basically, see what happened. Just like achar. Why you and me eat achar? Achar is a known prebiotic. It's stimulant. It's a symbiotic prebiotic, right? So it in fact stimuli our gut microbiome, right? So as far as there is for murghas, there is a word in English I am forgetting. So we work for NDDB on this. What they call it as English? I'm forgetting it. So
sort of pre-fermented food.
No. There's a typical scientific word for this. And it's a very well-known thing, and West Maharashtra, people are using it. Now they approached to me that the entire grass is wrapped in plastic. So, and a lot of
Yes.
plastic waste is generated on farm. So they were asking me, can you tell us some alternative for that? So I know the composition, it is highly acidic. The pH goes as low as 3.5.
Okay, sir.
So answer to your question is use of murgas. Many of non-Marathi people may not understand it, but I am also not recalling the English word for that. It's a well-known nutrient for ruminating animals. It's absolutely well-known. In animal nutrition, they are making use of different ingredients. Here at Akola, we have postgraduate PGIVS, Postgraduate Institute of Veterinary Sciences. What they did, they said that we have a lot of orange peel waste. So they use in that fermentation, pre-fermented food, they put the oranges also. Somebody tell that there is a lot of waste in mushroom also. And mushroom waste, we eat the upper part, they call it as button, but the stem is waste, right? That waste is a very rich source of protein. So people are using different composition. Typically, animal nutrition department people are making use of different organic waste as ingredient for this murgas. I'm so sorry for non-Marathi people that I'm not able to pronounce correct English word for that.
Thank you very much, sir. Thank you.
Thank you.
So can I ask a question, sir?
Yes, please.
I'm Mrs. Vaishali Tue from Nasik, only, sir. So most of the farmers, they cut the wheat after the wheat has been grown, or even the jawar and bajra, and whatever remains on the ground, the farmers usually burn the things. ते थोटके जे आपण म्हणतो सर मराठीमध्ये, ते फार्मर्स जे आहेत ते सगळं जाळून टाकतात, and then that creates pollution. So can you or do you have any means by in which you can treat the remains of the wheat or any other crops on the farm?
मॅडम तेच काम आहे, हेच करतोय आम्ही. what we initially started.
शेतामध्ये करता येईल का?
सांगतो. सुरुवात आम्ही अशी केली. मॅडम उत्तर मी इंग्रजीमध्ये देतो. What we did is
no problem.
What we did is we initially, because the industry is in contract farming, so it's a more organized farming. So they have a baling machine. So we have this paddy straw, all this straw and stack. They used to go cut, bale it, pulverize it, and use it. But what you are saying is absolutely correct. This is good for industry. What about the farmers, right? Farmer will not uproot it, and he will, for example, the region from where I am, Nagpur is all cotton belt, and the cotton stacks are extremely difficult to uproot also, because it has very high lignin content. So they also burn it.
Yes.
Right. Now there are two options. One option is biomass briquettes, but the biological option that I want to tell you is that today morning we are working with NDDB Mruda. Today morning I receive a call from NDDB Mruda. They are working with a couple of KVKs in Gujarat. What they did is exactly what you are telling about. After harvesting, the leftover maybe 6 inches, 8 inches above the soil, right? We sprayed our culture. When we sprayed the culture, after 8 to 10 days, you assume 15 days, not 15 days, but 8 to 10 days, the leftover, जे आपण ज्याला स्टॅक म्हणतो किंवा जे तुम्ही थुटे म्हणता आहात, ते सॉफ्ट होतात. They become soft, and the roots which are inside the soil, they become softer. They don't decompose completely, but they become softer. And farmers anyway goes for rotavator. So what they did in Anand and areas around that, this is with the farmers. मी ह्याच्याबद्दल नाही म्हणत आहे की आणलं आणि ते केलं. शेतकऱ्यांना जे उरलेलं होतं, तुरीचं होतं, तूर उरली होती, त्याच्यानंतर काही ठिकाणी सोयाबीन उरला होता, त्याच्यावर कल्चर शिंपडलं. कल्चर शिंपडल्यानंतर दोन प्रकार केले. कल्चर शिंपडलं आणि ते मातीमध्ये रोटावेटरने मिसळून टाकलं. रोटावेटर प्रकार माहितीये तुम्हाला?
हो सर.
रोटावेटर काय असतो? ट्रॅक्टरला पाठीमागच्या बाजूला अटॅचमेंट असते, राईट? So this attachment, so rotavator is a known machine with almost all farmers. जे जुन्या काळामध्ये बैलबंडीने केलं जायचं त्याच्याऐवजी आपल्या ट्रॅक्टरला पाठीमागे रोटावेटर असतं, and that rotavator has an attach, so the tractor has a attachment and that attachment goes inside the soil 6 to 9 inches and मातीची जी मळणी केली जाते ती त्याने मळणी केली जाते आणि मग जेणेकरून ते मातीत जातं आणि मातीमध्ये ते ऍक्सलरेट होतं. अदरवाईज काय माहिती बा, हा सगळा जो कल्चरचा जो रोल आहे इट इज टू ऍक्सलरेट द प्रोसेस. बाकी तुम्ही त्या प्रोसेसला थांबवू शकणार नाही आहात किंवा ऍट द मॅक्स आम्ही काय केलं बाबा, जे महिन्याचं होतं त्याला आठवड्यामध्ये आणलं. आठवड्याचं एन्झाईम वापरून तुम्ही 4, 5, 6, 8 दिवसात आणलं, पण तेवढा वेळ तर लागेलच त्याला.
So, but where is the culture available? So, where the farmers can get these cultures?
Yeah, thanks for asking this question. I asked my student who did all this work. I have one PhD scholar, another postdoc scholar. So they have a startup, and through that we are selling it. And as you are aware that we academicians are extremely poor in salesmanship and marketing. We are not able to sell properly.
So we grow paddy in our fields. We grow paddy in our fields, and we finally the man there he burns off the field. The remaining.
तुम्ही घ्या आमच्याकडनं, आमच्या माझ्या विद्यार्थ्याला मागा मी पाठवतो तुम्हाला. नाशिक अगदी जवळ आहे, ओव्हरनाईट नागपूरहून.
For that I want to interrupt. Vaishali and we both are colleagues. In our department, we have just started our work on such kind of enzyme production, all this. If you collaborate with us for such a consortia and at the production level, we will be happy to take the guidance from you. And
तुमच्या लोकांचं मायक्रोबायोलॉजी किंवा बायोकेमिस्ट्री बॅकग्राऊंड आहे का?
मायक्रोबायोलॉजी
बस मी तर पाटील सरांना म्हटलं आम्हाला विद्यार्थी पाहिजेत, आम्हाला काम करायचंय, आम्हाला मायक्रोबायोलॉजी येत नाही. सगळ्यात पहिल्यांदा लिंक्डइन वरती पाटील सरांनी मेसेज टाकलेला आहे.
ओके सर, विल जॉइन यू and give us your valuable guidance.
काम करतोय. एक दुसरं जे महत्वाचं काम करतोय, सुरुवातीला कोणीतरी म्हणलं काल ट्रायकोडर्माचा टॉक झाला, मला माहित नव्हता. आम्ही सेकंडरी मेटाबोलाइट्स वर काम करतोय. आम्हाला ट्रायकोडर्मिन पाहिजे, तुम्ही आम्हाला द्या तयार करून ट्रायकोडर्मिन.
डेफिनेटली सर, डेफिनेटली
आपण नक्की बोलूया है ना, आपण बोलूया.
Yes.
We are in dire need of support in biochemistry and microbiology. Because we are very good in chemical engineering. We are good in scale up, फलाना ढलाना, पैसे वगैरे, डिझाईन मध्ये. We are relatively poor in the science of biology. I mean biological sciences. Biotechnology आम्ही करून घेतोय.
तर आम्ही करू मदत तुम्हाला नक्की.
प्लीज करा मॅडम, प्लीज करा.
Definitely, sir.
Sir, we will be also interested in joining with you.
मॅडम प्लीज, तुम्ही कुठनं आहात मॅडम?
मी पुणे.
फारच छान मॅडम, प्लीज जे कोणी आहात आपण खरंच काम करूया. आणि बिकॉज लेट अस हॅव सम कॉम्प्लिमेंटरी. आय ऑलरेडी हॅव शोन यू वी आर वर्किंग विथ वेटरनरी पीपल, वी आर वर्किंग विथ ऍग्रिकल्चर पीपल, वी आर वर्किंग विथ स्मॉल ग्रुप्स ऑफ बायोकेमिस्ट्री, मायक्रोबायोलॉजी.
बरोबर आहे. And our students will also get very good exposure ki actually how biotechnology works, because means we talk so much about biotechnology, agriculture applications of microbiology, and so many things. I mean soil health, soil microbiology, so many things we talk, bioleaching and all that. But then you are talking about actual applications and use for the farmers. So it will be really essential, and it will be very good exposure. It will be very good for faculty. I mean, it will be very, useful for everyone, win-win situation. So definitely.
तुमच्याकडे कोणत्या ब्रांचेसची मुलं असतात?
आमचं ऍक्च्युली आहे बायोटेक्नॉलॉजी इन्स्टिट्यूट, but so we have BSc and MSc biotech. So we have all the subjects which are there. I mean, base is microbiology again. I am basically from microbiology. So
आपण सगळेजण एकदा बोलूया. संदीप पाटील सरांबरोबर आपण बसू सगळेजण. धन्यवाद आम्हाला सगळ्यांना जोडून दिल्याबद्दल.
हो, संदीप पाटील सरांचे खूप खूप थँक्स त्यांना की आम्हाला असं काहीतरी कनेक्ट मिळाला. आणि आम्हाला ओळख झाली तुमची. येस, व्हेरी नाईस, व्हेरी नाईस.
One of my student, Tejas, has got inspired from your some publications based on this valorization, and he had started work from last year on valorization by using enzyme cocktail.
वंडरफुल. हे पहा,
खूपच छान.
आमच्याकडे जोक मध्ये असं म्हणतात की पेपर पब्लिकेशन कोण वाचतं? जो विद्यार्थी असतो तो, आणि जो रिव्ह्यूअर असतो तो. गाईडही वाचत नाही. 2 रिव्ह्यूअर आणि हे. तेजस, मी तुझा आभारी आहे, तू माझा पेपर वाचलास.
Yes, sir. Actually, I am currently working on microbial production of enzymes and their use in lignocellulose valorization. So, मी तुमचे ऍप्लिकेशन पण बरेचसे फॉलो केले आणि मी तुम्हाला लिंक्डइनला पण फॉलो करतो.
तू काय नेमकं काम करतो प्लीज मला सांग.
हो सर, नक्की नक्की.
मी सांगितलं ना, आता चौथा माणूस आहे कोणीतरी ज्याने पेपर वाचला आमचा.
नाही सर, बरेचदा काय होतं, हे वर्क रिमेन्स इन द लॅब ओनली. सो टेकिंग इट टू लँड इज अ बिग थिंग. कारण म्हणजे त्याचं म्हणजे त्याला पायलट स्केलला नेणं आणि त्याच्या पुढे नेणं, ह्याच्याकरता वी नीड हेल्प. कारण आम्ही लॅब स्केलला पुष्कळ करतो.
प्रभू कृपेने मला चांगले लोक मिळाले, चांगले इंडस्ट्रीचे लोक मिळाले, केव्हीके चांगल्या मिळाल्या. माझ्याजवळ म्हणजे सध्या एक अशी परिस्थिती निर्माण झाली की एक फॉरवर्ड लिंकेजेस चांगले झालेले आहेत. एनडीडीबीचा विश्वास आहे. आज एनडीडीबीचं खूप मोठं नेटवर्क आहे. एनडीडीबी मृदाने आम्हाला पूर्ण मदत केली. नागपूर, मराठवाडा, विदर्भ मराठवाडाचा एक एनडीडीबीचा डेडिकेटेड प्रोजेक्ट आहे. त्या लोकांना हे दिसलं की एन्झाईम शेतकऱ्याने जर केलं तर त्याला फायदा होऊ शकतो. त्यांनी मदत केली. तर अंबेजोगाईचे केव्हीकेचे जे लोक आहेत ते येऊन गेले. त्यांनी आम्हाला तिथे बोलवलं. आम्ही शेतकऱ्यांशी, आता पहा, आपल्याला विद्यार्थ्यांशी बोलायची सवय असते, शेतकऱ्यांशी बोलता येत नाही.
एक्झॅक्टली. मला तेच खूप मोठी गोष्ट वाटते सर, की एवढ्या फार्मर्सना तुम्ही कनेक्ट केलं आणि त्यांना सांगणं, समजावणं.
त्याच्यामध्ये मी प्रामाणिकपणे सांगतो, ही काही मोठी गोष्ट नाहीये. आम्हाला चांगले लोक भेटले ज्यांना आमच्यावरती विश्वास आला. आज तुम्ही आमच्याशी बोलताय, तुम्हाला आमच्यावर विश्वास वाटतोय. तसेच काही शेतकऱ्यांशी काम करणारे चांगले लोक आम्हाला भेटले. ते म्हणजे ह्या गोष्टी जुळून आल्या आणि आम्ही प्रामाणिक प्रयत्न केले. त्याचं क्रेडिट मी घेईन. बाकी आम्हाला खूप काही येतं अशातला भाग नाही.
दॅट इज
तुमचा मोठेपणा सर.
मोठेपणा तुमचा.
नाही, मी सांगितलं, चौथ्या माणसाने माझा पेपर वाचला. कोणीही पेपर वाचत नाही.
नाही सर, रिसर्च करणारे वाचतात.
We microbiologists think that sir, we got the right person for the field trials or the field work. Otherwise, our work could be limited to laboratory.
Exactly.
And only in cases only.
Yeah, तेच होतं.
Definitely will connect you, sir. Thank you.
Thank you, sir.
So for non-Marathi people, excuse me, what I was talking was that how engineering and basic sciences, that too people with microbiology and biotechnology, can contribute in this particular work. And we were exchanging that as far as the biochemistry and as far as the science work is concerned, it is many a times they remain confined to lab, and whereas engineering people, if they make efforts, they can reach out to farmers and people. But engineering is relatively poor in science. So coming science, people with strong science background, strong experimental hand, with engineering people who knows design and a little bit of economics, if they can come together, it's a good synergy. That's the gist of what we were talking in Marathi.
Okay, I request Sir Ravi sir, you please finish.
Thank you very much, sir, for very enlightening and stimulating talk. And it was very interactive, very interesting, and I'm sure it will certainly inspire our students and the participants, to do something new in this interesting area. Thank you once again for joining us, and certainly in near future we will try to have more interactions, maybe in the form of conferences or seminar. So I look forward for your same kind of support in the coming days. Thank you very much, sir.
Thank you, sir. Thank you.
Now we have our next speaker. I guess he's already there in the lobby.
Yes, sir.
Ullas Patil, sir, are you there? Hello.
Hello. Hello.
I guess he's not there. I could see his name there.
Yes, he's there.
Can you please call him?
Yes, sir. Yes.
Hello.
Yes, sir. Yes, sir. We are trying to call you. Are you there, sir? Can you hear us?
Yes.
Yes. Welcome, sir. On
Good
behalf
evening.
of, I should not welcome you like that because, uh, uh, but still, anyways, I welcome you, sir, on behalf of my department and college. In fact, this is your department also. And I take this opportunity to call Tejas, to introduce Dr. Ullas Patil with our audience. Over to you, Tejas.
Yeah, good evening again. So it is my pleasure to announce, to introduce our next notable resource person, that is Professor Dr. Ullas Patil. He is currently working as a professor at the Department of Microbiology at Dr. Homi Bhabha State University, Mumbai. He has formerly worked as a director at Government Institute of Forensic Science, Aurangabad, that is now known as Chhatrapati Sambhajinagar. His core research area includes enzymology, pharmaceutical microbiology, protein purification, enzyme inhibitors, and etc. He has produced 14 PhDs in total, in which 7 students are already awarded and 7 are currently working under his guidance. He has a 23-year of teaching experience, and he has around several Scopus index publication with around 800 citations. He has completed 4 research projects, from which 2 are major research projects, and they are funded by UGC and DST. He has published around 6 books with various publication houses across India. He is the founder of National Level Microbio Olympiad, and we can proudly say that it was founded around 22 years ago, and it is active since then. Today, he will be sharing his thoughts on microbial innovations for driving Bio E3 policy. So I welcome Professor Ullas Patil, sir, to share his valuable knowledge. Sir, over to you.
Hello. I'm audible.
Yes, sir.
And what about the presentation?
You can share from your end, sir. Yes, it is visible. It is shared.
Visible?
Yes.
Visible?
Yes, sir.
Yes.
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 Okay, very good evening. A lot of known faces, known names are I'm finding. And, and it is very nice to interact with all of you. Let me first congratulate all the participants because they are attending and showing their dedication as far as learning is concerned at the very odd time, because this is a peak time we should totally give to our family, but still your enthusiasm is really appreciable. And not only to this, but also we also should be thankful to the organizers. They are taking painful efforts for these things. But Shirpur microbiology department have already known for that kind of work, and so I also wish the best luck for the future programs also. Now let's start with this topic: microbial innovation for driving a bio E3 policy. Actually, biotechnology is not known to us. A very ancient time will know that there in Mohenjo-daro, Harappa also will found that the peoples have stored their seeds in the one container, and that container is closed by the ash. So this is there are several practices. Use of animal for the agriculture practices is some sort of a biotechnology. But nowadays, a biotechnology dimension is totally different one. Is from the initial level to at utmost and progressing level it is there. And with that concern, by keeping all this point of view, a bio E3 policy is recently proposed. It is proposed by the Department of Biotechnology, and it is actually the bio means biotechnologies or the biologicals. Bio is there. E3 means one is for the economy, as another is for the environment and employment. Actually, this is the secondary follow-up depending on the sustainable goals. And so I am shifting my lecture to the sustainable goal and how the microorganisms can be useful in order to obtain that goal. So this is actually the word policy which is proposed by the United Nations, and subsequently every nation has to adapt their own policies, and in accordance to that sustainable goal, this bio E3 policy is given. As we are all biology students, teachers, and so we are much more happy as far as such kind of policies are announced, because this proposal is already accepted by the Union Ministry on 24th August 2024. It is also known, they say that this is the first kind of such kind of a policy. And its a purpose, as Prime Minister mentioned, that it is for the fostering the high performance and the bio manufacturing. And this initiative will definitely promote the green growth in the country that world global challenges are actually expecting. And if we get successful in as far as the implementation of policy is concerned, this is the totally going to transform the manufacturing paradigm to the regenerative principle, because much more waste we are creating, much more pollutants we are creating, and so urgent need is that actually all the things are very much urgent. In order to uplift the economy is important thing, and in order to appropriate progress, environmental damage should be under control, or there should not be environmental damage. And of course, every nation, and particularly in India, there is a need of employment. You have to integrate all these three things. In that sense, we hope that the government will be take its effort to implement this policy. And as students, as teachers, as entrepreneurs who are listening, their responsibility to utilize these things. Let me clear how many, what is the audience nature, whether it is heterogeneous or all are biologists?
Sir, it is from life science background. All of them are from life science background. The audience are research scholars, PG scholars, and most of them are faculty members.
Okay, thank you. Now, as for I'm not going to much detail as far as the microbiology is concerned, because suppose we want to implement the biotechnology, we can go towards the plants also, we can go towards the animals also. But I think microorganisms have more advantage, and majority of them are a unicellular. And unicellularity always allows us to handle them as per as our wish is concerned. For example, suppose I am cultivating the plant will grow as per it. It will require the space and all these things according to its need. Same with the case of the animals also. Some sort of climatic conditions are there. And many times in case of plants and animals, we have to take advantage of the environmental condition. Means these are the environment dependent catalyst of the biotechnology. But instead of that, if you shift toward the microorganisms are very systematically grown under our controlled condition. Whatever things they required, if we know, we can create the thing. We create the things, and in this, all organisms are equally important. Whether it is a algae, whether it is a fungi. Excuse me, sir. We have
Hello.
Hello.
Someone is disturbing. Yes, I have muted all the participants. Yes, sir, please continue.
Now, all are the important components, whether it is the protozoa, whether it is actinomycetes, fungi. Even the protozoa are very much important as far as the environmental things are concerned. And also we see towards the viruses as a culprit, but viruses have the very important role as far as our evolutionary concepts are concerned. Today is not a topic, but the viruses are also good. Just like a dag achhe hote, the viruses are also good. Only thing is that we are not aware that what kind of sustainable environment they want to inculcate as far as this planet is concerned. So this thing has a very positive impact, and I think it is one of the power. Hence, we can say it is a microbial power, just like others nature's powers, like water or the fire or the so many things. This is a microorganism togetherly. Secondly, you can implement, we can take advantage at 3 points. First thing is that wherever they are present, as it is, without any interference, they are serving for our development. They are serving for creating our environment clean. Means even we are not take care of them, still, despite of them, they are working. At second dimension, suppose if I succeed to isolate one of them and know the potential of it, and then I can implement for development of a technology that is we referred as a biotechnology. And in from 1970s to up till now, a majority of things are based on these things. We have to systematically isolate the culture, efficient strain, and then things without any manipulations. So that is the second dimension. Third thing is that they also allows us to manipulate their structure. Okay, due to virtue of genetic engineering itself, the birth of this genetic engineering is due to the microbiology. The microorganisms themselves given us several enzymes to us, and they also allow to their manipulation. And so at that level, at the 3 levels, we can take advantage of the microorganisms. And hence, suppose we want to implement, we have to promote this policy, a nationwide policy, we should give the priority, we should give the much more emphasis as far as the microorganisms are concerned. Although you know that you are not have such impression, but generally in public, even in the case of farmers, whenever we interact, in case of hospitals, definitely the role is there. But as far as other spots are concerned, generally microbes are considered as a harmful, but it is not like that. And today we know that only less than 1% are the human causing involved in the animal or human diseases, and 4% plant diseases, and remaining 95 are they are contributing for us. Now, whenever there is a sustainable development is there, sustainable developments, whatever things, whatever natural resources are there, I am going to utilize it. And my expectation is that I should utilize in such a way that my next generation should also efficiently utilize. That will also there. At that time, it is not possible. Something is there that is definitely going to exhaust. Only thing will not exhaust that they are under the cycle. So, for example, water is a cycle, and hence from the number of generation we are sustainably utilizing it. Although due to our disturbances we are contaminated all these things, that is the different story. But the nature have created a mechanism, a cycle like mechanism. So similarly, as far as our resources, our technology, suppose I want to protect the environment, I want to employ the people, and I want to establish a manufacturing unit, the hope goes to the microorganisms. Why microbes? Because microbes are the ancient form of lives. 4 billion years ago, the first cellular life is created. This is the yellow line shows. And now also this is the well-established life is there. And meanwhile, what happens? There are different changes that takes place as far as the global or Earth environment is concerned. The climate is drastically changed. For example, initially there is a barren thing, a sterile thing is there, and so a lot of activities are there. But when the life is generated at that time, also a lot of difficulties are faced by this life, because at that time the life is originated in absence of oxygen. Then later on, they are modified, and from the water, they are splitted, and some unoxygenic phototropic bacteria created the oxygen, and then oxygen once again created a problem, then cyanobacteria in that way. What I'm saying that these are the long experience. They have the longest kind of experience to tackle the different conditions. Okay. I also aware about the one of the share that the जब हम नहीं थे तो खुदा था, जब हम नहीं रहेंगे तो खुदा होगा, और जो भी कुछ बिगाड़ा है वो मेरे होने से बिगड़ा है. आई वांट टू मॉडिफाई, जब हम नहीं थे तब माइक्रोब्स थे, अब जब हम नहीं रहेंगे शायद प्रोबेबली तब भी माइक्रोब्स दे कैन सर्वाइव, एंड जो कुछ बिगाड़ा है दे कैन आल्सो इम्प्रूव. ओके, and henceforth we are very much hopeful as far as the these particular bacteria or microorganisms are concerned. The first point is that they are ancient life forms and they have experienced to tackle a very hazardous, very extraordinary condition which is not support the growth of us, and henceforth they are the hope for us. Secondly, microbes are the toughest life forms. Okay, if you go to the hyperthermopile, means extreme temperature tolerant, means 122 degrees Celsius is the highest limit that any life can tolerate, and that is by the methanopyrus. That as far as lowest temperature minus 12 degrees Celsius, that is also by the microorganism Psychromonas. Then extreme acid, okay, if the up to the 0.7 or less than that also, such extreme acid, that is also tolerated by the one of the microorganism, that is a Picrophilus. Then alkalophile, extreme alkaline condition, that is also tolerated by the Natronobacter. Then extreme pressure, just below the sea, there is also once again the microorganism is there. Extreme salt concentration there. Means although elephant is used, whale is used, shark is used, but they can't tolerate such extraordinary things. And henceforth, they are the toughest form of life. Toughest form as well as the normal form, all the varieties are available. And as they are the more toughest form and we are drastically changing our environment, we are increasing the temperature, we are disturbing the environment with acidic, alkaline things or the salty things or the xenobiotics. Here, the toughest form of life easily gives us answer to us. Another reason that why we should see toward the microorganism hopefully, because as this is the biomass, total biomass. So on the terrestrial environment, you will find the major biomass is of the plants. Then that is followed by the soil fungi, then soil bacteria, then protista, and then these are the arthropods and this. And the animals are very, humans are much more less there. Although we say that we have the higher population problem, but as far as the biomass is concerned, a very small dot is there. Even the total weight of all these organisms, microorganisms, is much more than us. And henceforth, we should not take much more thing to be a fear, because a major biomass is associated with these things. Means suppose we are the negative, we are playing a negative role as far as the environmental degradation is concerned. There is a much more positive things are working with respect to the environmental management. Secondly, in case of marine also, you'll find the protista are more, bacteria are the more, then arthropod, and then fish. Means there also the more proportion is a microorganism. Then at a deep surface environment, you'll find the terrestrial bacteria are more, because there are the totally drastic environment is there, high pressure, high salt concentration, all these things. That is followed by the marine, then archaea, marine archaea. So these are the totally predominated by the, and this is the overall picture, word picture of a biomass of cell segments. And henceforth, I think forget about plants have the positive role as far as environment is concerned, but as compared to other these animals and all these things, there is a much more positive pressure. And so I given the word microbial power to such kind of things. Now, what is our problem? The 5 topmost problem, if I surveyed on media, they will find that there is a climate change, environmental degradation, poverty and inequality, global health issues, food and water insecurity. And fifth is the conflict and the political instability. In a single glance, as you are the biology, you can say that all 4 problems are closely related, appropriately tackled by the microorganisms. A fifth also indirectly tackled. Okay, there is one story I want to share with you. For example, our nation is getting divided in 1947. I mean, independence and division both are the same years, Pakistan and then India. At that time, Muhammad Ali Jinnah taken a lead, and he has a wish. Majority of peoples, majority of political leader from that region of Pakistan, current and India, they are not in support of a division. Only strong belief is by the Muhammad Ali Jinnah. And at that time, the political systems or our systems are not aware that the Muhammad Ali Jinnah was suffering from the tuberculosis. If he is suffering, and he also died due to that reason, and he died just after the 13 month. Okay. Suppose if the tuberculosis bacilli, actually we should not talk like that as far as the death and birth is concerned, that is a totally incorrect. But if the tubercle bacilli has the higher incubation period, there is Jinnah will die away and there is no spread of death. And so I can say that even the microorganisms has a much more impact as far as the political systems are concerned. There are so many reasons that so many politicians, they believe that they are the character, but they are detected with the syphilis and all these things. That are the different kind of story. Means overall, my say directly, indirectly, the microorganisms easily touch the topmost problem as per as these global challenges are concerned. And depending on that, we know that there are 17 goals are proposed by the UN, and that are well displayed on their website also. And they're promoting all nations to please have your own, have your progress. Everything is essential, but whenever you are thinking about the progress, you should think these 17 points. As far as these 17 points are concerned, as far as biotechnology is concerned, these are the second number, that is the zero tolerance. Then third is the good health and well-being, gender equality, clean water and sanitation, then the affordable clean energy, industry innovation and infrastructure, then responsible consumption and production, climate action, life below water, life on land. These all are directly concerned to the microorganisms. They have a direct solution with them in order to tackle, in order to optimize this. What about others? Whether no poverty and all these things, these are also controllable. Okay, but these are the indirectly tackled by the microorganisms, whether it is a quality of education or the other whatever points which are just four points are missed. But these are also the indirect. But these whatever I encircle appropriately squared here, these are directly concern of microorganisms, and we can take advantage of them. And then, in order to, whether it is a word who is wishing to implement the sustainable global goals, or whether our nation is implementing the bio E3 policy, I think a microorganism, a microbial power will definitely, because of different characteristics already given that this. Now, one by one, we are going to. And first is that the way should do, how we can harness. If I am saying that it is a power, then we should appropriately use it, because whether it is electricity, whether it is the water, whether it is the sunlight, these all natural powers. Until and unless we are not capable to harness them, they are not useful for us. When we are use the water for the irrigation, then and then agriculture gets flourish. When we are appropriately recycled that particular water and then generated the electricity and appropriate energy is transferred, then and then similarly here, because microorganisms have a much more impact. They have to ultimate owner of this planet, hence they have to think regarding to the, they have to promote the growth of flourish the life also, and they have to control the life also. Their role is totally different. How I have to harness the power of microbes for achieving the zero hunger. Zero hunger, that is the lot of small to broad meaning might be there, because total lack of hunger, that is one thing. But although those who are like we are not hungry people, we are the satisfied, our society is satisfied, but what happens, still we have a taste hunger, we have the innovative food consumption hunger. All the kinds of hungers easily compensated by the microorganisms. Why? Because microbes are the integral in the food production. Directly, indirectly, there is a role of microorganisms. While several microbes are also, we are finding they are involved in the spoilage, and henceforth, suppose we have to consume every and each person on this planet, we have to also take care of the what, how the microorganisms are going to spoil them, and we also have to appropriate have the sustainable technology to appropriately utilize the food for the apple. The soil microbes aid in the plant growth, indirectly involved in the food production. Then various microbes are direct producers of food through the fermentation. The fermentation products are there. So in that way, a zero hunger. Zero hunger means not to just supplying the food to everybody, but along with that, the food should be a nutritious one. It should contain appropriate calorific value. And now a biotechnology, a microbiology, or all subjects are permit to aware about these things. And hence we can see toward the microorganisms in a very helpful manner. Now, already in the market, you will find the bioinsecticides are there, then the organic compost are there, nitrogen fixing organisms are there. But only thing is that awareness is not there, or as far as their transfer, because there is a paradigm shift we are expecting, and for that purpose, technologies are there. Although a lot of technology or beautiful technologies are available, but their implementation is not there. As a teacher, we are aware that why, despite of having a very efficient role of azotobacter, why the farmers are not there. For example, I am searching one culture, even I'm listening the formal lecture also, and they're asking that the from where we have to obtain the culture. And that is really a problem. For example, if some factories there they are producing the azotobacter and that is in Mumbai or in Pune, and suppose one farmer is there live in Shirpur, and suppose he want to apply such kind of fertilizer in his field, then he purchase. But what happens? There is the azotobacter is synthesized, packaged, then later on it becomes in the godown. From godown it is transported to the Shirpur, then bring the Shirpur in the shop that remains. Many times it goes much more 1 month, 2 month is time is there. And after 1 month or 2 months, whenever you are applying, at that time the count is of course lowered, because if the humidity, available water course is not maintained, then definitely we know that the microorganisms not survive there, and all organism, all preparations are not a spore formers are there. Henceforth, suppose if such a is there, nowadays, although farmers say that he has a satisfaction that I have applied the azotobacter and I am doing the azotobacter, but he not get a appropriate result. Why? Because the count is already known. Now, what is the challenge? We have the challenge that we have to establish the unit in the Shirpur itself, in the Nashik itself, in the every thing, and they have to supply it a fresh. And that is also some sort of a socio-economic way is important, because a farmer is not a person from which we can take a much more advantage. It is not a business like thing. But many times what happens, such organic farming people are also doing the business and also doing, and as a these are the things associated with this. Henceforth, there is a appropriate need. Suppose you want to prepare your students, or the as a teachers you are want to involve, you have to think as far as this point is concerned. If you get a spore former organism, it's okay, but still there is also that appropriate research is needed, because many times what we say, suppose I have the spore former culture, so Bacillus thuringiensis is a spore former, and then it can remain for the 250 years. Theory is known. But suppose I want to apply whenever in the field, still also to germination is not only happens due to the water. Along with that, several stimulating factors, several amino acids are required, and henceforth that knowledge is still not open to us. And in that directions, as far as our research is concerned, as far as our technology is concerned, we have to think then and then. Secondly, the microbes are the cook. Okay, and from so many generations, alcohol, then the bread, and then the vinegar, and the pickles, and the cheese, and the beer and wine. These are very efficiently used, and so many nations have developed, maintained, nurturing their economy based on these products. But still, we not okay. Uh, for that purpose, microorganisms provide the things. And here, what happens? There is a need to have adapt a innovative approach. Just I want to share two paper work by me and my students. The first is that there is a one organisms were isolated, fructobacillus fructosus, which is obtained from the Butea monospora. In Marathi, we say the palas. पळसाला पाणी तीन असतात तर तो पळस. So these Butea monospora flower, and actually we are in searching the probiotic culture, and when we see the different flower, and we are just collecting the flowers, but at that time, we never got this particular nectar associated with the Butea, because insects and these ants are already sucked that particular thing. But after continuous visiting, we collected that. In the Butea monospora sperma flower, a nectar is there, and from that nectar, we have isolated this strain, that is the Fructobacillus fructosus. We have deposited also. Fortunately, I am sharing the same work where I have performed the work there, although the affiliation, yes, there is an affiliation architect. Now, at that time, what happens? This fructobacillus fructosus we get, and then we analyze whether it has the probiotic activity and all these things. Then we found that these organisms have a preferential capability to utilize the fructose. Okay, means lactose glucose if it is given, then this organism preferably use the fructose. Hence the name fructobacillus is there. It is a new species proposed by the Indo. Now, what happens here? Meanwhile, I also have several literature survey, and that the fructose, high fructose syrups are related. There are several papers that due to the high fructose consumption, which is a part of the high fructose syrup, obesity is there. So there is a physiological conditions, and that fructose is contributing to the obesity. But the fructose as the sweetening index is more, hence for America and majority of European countries are manufacturing the high fructose syrups, and they are promoting the they are also adding in the different kind of food preparation. But one of the obesity factor is that due to the high consumption of fructose, the things are now. Here are two hungers are there. My tongue wants the sweetening, hence why technology shifted to the fructose. But my gut physiology not allows, because elevated concentration of fructose induces the other parameters which make me obese. Now we have correlated these things. There's a fructobacillus, for example. Yes. Yes. Whether I am audible?
Yes, sir.
Hello?
You are clearly audible. Yes, sir.
Okay. Okay. Now what happened? Suppose if I consume the high fructose syrup, and along with that, if I taken this culture also, which already has screened it for the is a probiotic potential, it is not harmful to us. Then it is possible, because whatever excess of fructose which is consumed by me, that will be utilized by these organisms, and such kind of obesity problem will not get. Means what is my point is that we have to search out the such kind of a innovative thing, and then we can promote a biotechnology. Another approach which is here in the where use the Bacillus subtilis. This culture is this organism is isolated from the insect, which is the obtained from the soybean, which is targeted by the some insect, and from that gut we isolated the Bacillus subtilis. Then what is the problem with the soybean? Soybean is many time allergic. So many persons have facing the problem of allergic, and due to the allergy, many times they are not preferred by the some population, or those persons who are finding allergy, they not consume. But what will happen if the allergen protein will be degraded? It is not tackled by our body or my microflora. And so we have tried that the suppose if this insect is there, and if it is degrading, secreting the protease, that protease is degrading that particular allergen part also, that we are say, and we have proposed the potential that this particular strain is very efficiently useful for the degradation of the allergen. Means suppose I am preparing any soybean products or the soybean chunks or all these things, along with that, if I add the enzyme or this culture itself, that will take care of degradation of allergen. And those people, those population which can't take this particular due to the allergy, they can easily can inculcate them as per as this food preparation strategies. In this way, these are the things. Then for the next purpose, that is health and well-being, whether we can use the microorganism. Of course, these are the very direct relationship, because the majority of infectious diseases are due to the microorganisms. Prior to shifting to the next discussion, I just want to show the comparison. In the 19th century, the major killer are the influenza, tuberculosis, gastroenteritis. These are the topmost killer. Along with that, infant disease, diphtheria are also there. And then there is a followed by the heart disease, stroke, kidney disease, or the you can say that the lifestyle diseases are the less. But the major killers are microorganisms. But now today the situation is totally different. Whatever topmost killer influenza and pneumonia, these are the less, and very less number of infectious diseases are there where nearly solve this particular problem. Now, today's problem is heart disease, cancer, stroke, pulmonary disease, and not microorganisms. COVID is a different story that I'm not going to correlate with it because that has a different purpose as far as environment is concerned. But today, world is not having a much more problem as far as infectious. And why this thing is happened? Due to the hygienic practices, disinfectants, and then antibiotics, and all these things. These are contributing as far as the such kind of shifting is concerned. But friends, what happens, although I am saying that there is a drastic lowering as per these things, and the reason is that due to the development is there, but this also suggests that our development as far as medicinal field is concerned, it is not a sustainable. Why? Because heart disease is less problem, but now this heart disease is there. Then question arises that it's at the 19th century heart disease is there, and why today the heart disease cancers are predicted. Lot of theories are there. We have changed our lifestyle and all these things. We also changed the diet and all these things. But many scientists, many papers are there that they're correlating heart disease, cancer, stroke, pulmonary, even accident, your mood, that are indirectly under the control of the microorganisms. What happens while controlling the infectious disease? What are the use the antibiotics and all these things in very high proportion that they have disturbed our positive microorganism. And in absence of positive organisms, our body creates some culprit molecules, and these are promoting heart disease, cancers, and stroke. Whether there is a direct relationship, yes, majority of papers are there, but actually the science of microbiome is just recent one. In 2008, from the 2008, it is actually started, and hence lot of links are there. You will find the papers, they are just going to give the name. This organism is present there and there and here and there, and they are not knowing actually the things, but still, sir, papers are there. They are saying that these are there, and hence one of the hypothesis, one of the belief is that as these particular things got a victory over the infectious agent, but they are also created a paradigm shift as far as these things are concerned, and that is also contributed due to the absence of microorganisms. One thing already keep in mind that many times for the person death, the microorganisms might be there. It can be a reason for the death of a person, but for the life of a person, life of all person, a microorganism's role is important. Now, here also, this is another slide. You can see that how the nature itself is sustainable. Here I have shown the comparison between the deadliness or a fatality test. Means suppose if infection is there, then there is a chances of the death more than a 75 to 100%. So, for example, rabies. Some person bitten by the dog, and then if rabies is developed, and if it is not taken care, then definitely the death is there. And prior to Louis Pasteur, it is a proverb that if the one person who have a snake bite can survive, but the dog bite person never survive because of the rabies. They will find that whenever the rabies or HIV infection is there, so there is this deadliness index is the 75 to 100%. Okay. But as far as the transfer is concerned, you will find that the rabies is not a communicable. The communicability is the less. Means those diseases which are highly communicable, okay, like these measles and malaria and mumps and all this, they are contributing for the less death. But this is the very natural things are there. Even HIV is communicable disease, but the mode of communication is totally different. We can easily avoid it if you take a proper. Even at ancient time also, this particular thing is easily available. So as far as these things are concerned, if the means here you will find there is a totally inverse, means those which are deadly, they are not communicable, and those are easily communicable, they are deadly. So in that way, you can also see that the nature is a so whenever we are discovering the drug, at that time also this point should be taken. Suppose, so for example, whether which kind of a drug, what kind of patient care therapy, and all these things are required as far as their maintenance and all these things are concerned. And hence, you'll find here that this is extremely communicable, but that goes here, very communicable, that goes here, and in that way, vice versa. In there might be some one or more exception might be there, but this is the important thing. And we can see that the microorganism, although their role is negative, but in very beautiful way, in very sustainable manner, they are playing their negative role. So example, many we discussed that I have the problem of a dandruff, but dandruff is not so much problem. We take a very causally in that way. The dandruff is, although the universal problem, 99% people are suffering from this dandruff, but there nobody has taking much more health issues and all these things. In that way also, that is also one of the hint that how should we promote our biotechnological discoveries. Also, this is a very beautiful example that the generally the particular at age, lot of pimples are there. Okay. That for the beauty, girls are appreciated by the dimple, and very exact thing happens when she has a pimple. The pimple is a problem of particular. Then we know that as a microbiologist that this is the contributed by the Propionibacterium acne and Staphylococcus aureus. These are there. But suppose on my skin, if I have a Staphylococcus epidermis abundantly present is there, automatically it not allows the other organisms. Mere presence of this is sufficient because there is a specific space as far as my skin is concerned. Definitely some kind of microorganisms will establish. But suppose if my flora is established, my conditions, my physiology or my environmental, if Staphylococcus epidermis are predominated on my body, then automatically Staphylococcus aureus and C. acne are not growing there. And if suppose if it is lowered, automatically they got a scope and they got excess. So what is the problem? This pimple problem is due to the excess growth of Staphylococcus aureus. And what we are doing? We are applying the various creams and all these things and so many things. Actually, already there is a hormonal imbalances. Due to this, the skin have a tackling these things, and you are increasing a more problem by adding a ointment and all these things. Okay, just by seeing the advertise or the companies promoting policy. And what happens due to this cosmetic or the antimicrobial, even the Staphylococcus epidermis get lowered and this is also get lower. And whenever this got lower and this particular form resistance and that is established and that make a problem more complicated. Why not goes for such a kind of a cream which will supply the Staphylococcus epidermis? So, for example, one cream which consists of the Staphylococcus epidermis I am applying on my skin, and as abundant of Staphylococcus epidermis are there, of course, there is an inhibition of the Staphylococcus aureus. Why not I have such a cream which will promote specifically the Staphylococcus epidermis? Because solution is already there. We are interfere this, and henceforth that is the thing. And henceforth, this is the one of the beautiful strategy in order to boost the biotech policy. This is a very beautiful example, which is published in 2007 by the Webster. What happens? There is a one organism, protozoa, Toxoplasma gondii. There's a toxoplasmosis. So generally, what happens? There is a relation between a cat and a mouse. The mouse and cat, we know that the predator relation is there. So what happens? This particular mouse have a ability to smell the urine smell, and that nose is much more sensitive. It can easily can trace out that the cat is somewhere here and there, because wherever the cat is there, the urine smell is there, and such urine smell is easily perceived by this mouse. Because what happens? This is the nature have conferred that the mouse should properly protect from the cat. But what happens in such a case? What happens if the cat will not get mouse? How she can survive? So for that purpose, nature have another things. The some mouse have an infection of the Toxoplasma gondii. Those mice which have the infection of the Toxoplasma gondii, there is the physiological disorders are there, and that contribute to the alteration in neurons. And due to this, what happens? The mice lost the ability to perceive the smell of cat. And what happens if those mouse which are get infected by the Toxoplasma gondii, they can go in front of that cat. We have the proverb also, बिल्ली के गले में कौन घंटे बांधेगा, तो ये घंटे बांधने वाला, which is infected by the Toxoplasma gondii. Even the kind of observation we can find in our regular cases. I'm not aware that how many of you have visited the family who is have pet animal, cat and dog and all these things. But I have so many persons. I have visited their home also. The one madam is there. The 9 to 10 cats are there, and they are going here and there. And whenever we entering the door, it's a typical very off smell is given. We hate to enter in that. And I surprised that how this particular person is not tracing such kind of smell. So that might be that persons are also get infected by the toxin, and that is also predicted as far as the Webster's paper is concerned, that the we are giving response, means somebody like a dog very much or cat very much, and somebody are totally hating this. Actually, these are not you. A particular kind of microflora which is present in our body, that is appropriately synthesizing biomolecule. They have the effects on the neurons, and the neurons have the effect on the such kind of things. And henceforth, as what I say, that even the accidents can also indirectly control by, because if your mood is not appropriate, if you have the acidity, if you have the wrong kind of organisms are there, and henceforth these things are concerned. Henceforth, uh, these are very much important aspects which is explored here. Whether you are listening, hello.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Sir, yes, sir, we are
Okay.
listening. We all are listening.
Interesting.
Okay. Now,
Interesting.
next thing is that I already given that the story of one boy. There is a movie also on this on boy in plastic bubble. David is the he has a severe combined B cells and T cells are not synthesized genetically due to genetically severe combined immunodeficiency syndrome, the ACID. That due to this, what happens from birth, he has not T cells and B cells. We are microbiology or the biology peoples. We know that how these both the cells are very much important in order to protect them. So what happens? That particular boy is survived. They have maintained a sterile container and all this. Even you can see that very nicely represented in that movie. We also try to show the several clips of this movie and the microbial Olympiad. They are giving the sterile key books and all these things. But still, after a 12th year, that particular boy is get died because of not infection, because of a scarcity of important vitamins. Because we can nurture the life without a microorganisms that can survive also, but can not extend. Because in order to develop our bodies, for example, in our daily E. coli is supplying B vitamins, vitamin K. Okay, these are the things, and henceforth, microorganisms playing very important role. Is just whatever these are known things, and are not given much more weightage. Whatever new discoveries are there that I explained. Along with that, these are the vaccination. For the vaccination purpose, the microorganisms are required. They can maintain them as a bodyguard. Just I have given the example of a Streptococcus epidermis like that, or lactic acid bacteria. Such kind of things are there, and we already know that our human body contains 10 times more microorganisms, and generally our only up to 2% genes are active as far as our cell, whatever ego we have. So that is a contribution of a 2%. Majority or diverse kind of microorganisms are interfering or controlling my physiological conditions or and all these things. And that's why in many times uh, we ask the question whether you are a veg or non-veg. So that is not a much more important question. See, prefer the food which will not disturb your microflora. Whether you are consuming the veg or non-veg, that is not a much more matter. But if that matters, if we are introducing a wrong kind of microorganisms, and microbiologists are very well aware, biotechnology are very well aware to tackle such kind of things. There we can promote the probiotics and gut health related things. Whatever knowledge which is available, that we have to take a trial in laboratories. For example, so many Ayurvedic drugs are still waiting for their things. Then the microbial medicines, you know that there's so many things. 70% of the antibiotics are obtained from the streptomycin alone. I'm not talking about fungi and all these things. 70%. Then microbiome therapy, that is a new concept. Vaccines and biotherapeutics, bioengineered microbes. These are the various way by which we can harness the power of microbes and help to promote the bio E3 policy. There are a lot of arguments that what microorganisms can do with the gender equality. In my during reading, after seeing this movie, I have added these particular things. Whether I've seen this movie, Lapata Ladies?
Yes, sir.
I hope that many of you have seen. If not, so I suggest, I request you. Why? Because very proudly I can say the heroine, that particular role playing one character Jaya, she is very efficiently saying, I know the organic farming knowledge. Actually, the aim of these movies is totally thing as just like a title Lapata Ladies. We also found that the women are not getting appropriate weightage as far as their developments are concerned. Okay, and politicians are also taking advantage of it. This and all these things. This even in scientific world also we have find that there are n number of examples that where the women are suppressed. So whether the microorganisms can do anything, yes. Actually, whenever women are come in sciences, they always there is a nice contribution by the Barbara McClintock and all these things. There are so many ladies I can say they can contribute. Along with that, what happens? There are several physiological problems associated with women as far as health issues are concerned. Okay, so for example, cervical cancer. This is the very common major issue as far as woman health is concerned. That is not a problem for the and as for here we have to give the weightage as per these things. Even their microbiome is totally different. In when I'm correlating the microbiome and our thinking pattern or brain moods and all these things, at that time, women are expected to go from the very typical different kind of scenarios. For example, nurturing the babies requires a lot of patience and all these things. And so they have a different kind of a flora and it is needed to be studied. And hence, for gender, say for example, if any health issue, women generally nowadays facing, suppose I have a appropriate biotechnological drug or appropriate biotechnological solution I had, and if I provide a comfort as far as their life is concerned, what is else than this? Then they, if they are crossed that barrier, they are equal already. They have already the potential. Due to the some kind of differences, they are lapata as far as our things are concerned. Many times you will find they are very good farmers and henceforth sort of knowledge is there and henceforth inclusive policy and capacity building microbes are directly contributing. Secondly, they have very various different kind of ways because they associated cooking and all these things and for how to tackle with the microorganisms. Okay, I every time ask to my mother, कालची पोळी उरली आहे 2 दिवस झाले खाऊ का नको खाऊ then she say yes, तू खाऊ शकतो किंवा नाही खाऊ शकत. Okay, in that way. Although I am a microbiologist, but why I am asking to my mother that whether I should लाडू आता महिना झाला तर मी खाऊ का नको खाऊ. ती सांगते की किती झालं काय होतं कसा लागतोय थोडासा खा कसा लागतोय बर असं लागतोय का नको खाऊ. So this knowledge is already there. So this such kind of gender equality is possible with a proper microorganisms. And one of the very good example that no doubt that the Robert Koch, Antonio Leeuwenhoek, and Louis Pasteur, they are the first person. They have helped us to see the microorganism. But without a microscope, we capable to see the bacteria on the plate just despite of the very important contribution of the Fannies. And she was not a trained microbiologist. Why? Only there's her husband allowed to interact with it and share something and hence coding. Even in case of Robert Koch, actually it is title of my next blog is that. But in Robert Koch, at the 27th birthday, his wife given a microscope as a this thing. So you can say that the if Robert Koch can, he is a physician and he is searching the Koch that particular tubercle bacilli. But what is inspiration? Somebody is presenting a microscope. So that is the things. Hence, for there is a very positive role of woman as far as microbiology development and in micro also give the lot of returns to the women. They have potential. Hence, for this kind of thinking while accommodating because one of the bio E3 is the employment. At that time, there is a direct, indirect, a lot of solutions are associated with this that can be include the women. Then clean water, once again, sanitation and clean water, wastewater treatment, biological sewage management, pathogen removal, biosand filters, no chemical, no physical method, friends, available that can give a solution. Microbial solutions are the perfect solutions and hence recently in a Yes, 2019, one report is submitted on American Academy of Microbiology, American Geophysical Union, and Gulf Mexico Research Institute. They have discovered so many lot of organisms which are not known to us priorly, and they are submitted in this report. And they found that the and ocean level, when oil is going inside, that this at this particular type, when the initially organisms are degraded in some component, then transfer into another thing, then in sedimentation there is another challenge, and that at this height there is a different kind of microorganism, then at that time different kind of micro, in that way at the different sea levels a different kind of things are working appropriately. Either they are dealing with the sunlight here, in absence of sunlight they are with abundant of much more organic matter, less organic matter, abundant of xenobiotic, less means here will they are find that the lot of organisms are appropriate ways to efficiently degrade the things. Okay, efficiently means what happens we generally compare with our speed. Okay, but as far as the nature is concerned, it requires something. And so they have isolated the different kind of organism. They are listed also there, and these are documented. And now these, if you systematically utilize, they can also provide to clear the water or solve the problem of our sanitation as far as our uh, wastewater treatment and all these things are concerned. So that is the one of the positive things. Means one scientific community here also one of the important challenges that the majority of things are known nowadays. Only thing is that their problem of the implementation. Implementation problem is associated with the two things. At the political level, such implementation problems are there, and secondly, a society is also very stubborn, not accepting the things easily. But all these roles you have to play, and we have to establish various kind of local entrepreneurships and all these things, and promote such kind of technologies. So here you will find that how these particular sanitation practices are lower, and now a topmost it is referred as once upon a time tuberculosis is referred as the captain of diseases because major killer. But nowadays, even in ancient black and white movie, suppose the director want to kill the death of that hero, so in Raj Kapoor movie many times, so they are saying that they is suffering from the tuberculosis. So nowadays we can't show like that because the tuberculosis person never die. But at that time, tuberculosis person die. Why such kind of things are there? Because of the such kind of discovery and all these things. But where also you have to appropriately design and plan, and then sustainably execute the things. Then harnessing the power of microbes. Actually, this is the particular today or in this current time. Every word is saying about the clean energy. The microorganisms offer a microbial fuel cell, biogas, biodiesel, hydrogen, and these all are the clean energy sources and definitely promising things. Here also the much more research is required. During my childhood, I find that in all villages, even you can trace out there might be there. The biogas tanks are there. Biogas implementations is there, but later on, later on, I found that the although these tanks are there, but these farmers are not using the biogas. At that time, they every day they add the cow dungs and all these things. During my fourth standard, I think, miss this is the story of 1980. A lot of villages have the abundance of the biogas and their own. Then later on, that is not sustainable. Why? Because that might be hectic for us that we have to take a cow dung and add and all these things. What happens as a biotechnologist, we should also provide the things. And secondly, this is not efficient one because cow dung is already the utilized things. Okay, methanogens are source of methanogen is there, but actually the major portion, major energy compounds are digested by the cows in the stomach and ruminant organisms, and very little is there. Means whatever things which is created gas, it is very little. It's not efficient. There are some technical things are also there. Means now we also not expecting that everybody at this time that they have to collect the cow dung and add at the morning. That is not possible, and it is of course not possible. But suppose if you have some whole common biogas plant as far as villages are concerned or these things are concerned, then definitely that are going to give the things. Here also the lot of discoveries are there. Only thing is that the implementation problems are there. So in the research paper, these things are there, but if you appropriately implemented, then definitely. So same with the case of the biodiesel and hydrogen. Hydrogen is the you are aware that this thing is the important hope as far as the future world is concerned, and the lot of algae have the playing the role as far as the hydrogen production is concerned. Then suppose you want to develop a industry, innovation and infrastructure, the microorganisms are essential because pharmaceutical and food productions are totally based on this particular thing. There is a tremendous benefit of organic power of microbe to convert the renewable resource into chemicals. So many chemicals, formerly these are synthesized by the synthetic way, but due to the discovery of the green synthesis approaches, particularly non-aqueous enzymatology. Myself also work on this particular topic. And in a non-aqueous enzymatology, the enzymes are creating the chemicals. Okay, and enzymes are not a problem. Generally, what happens, several catalysts and the chemicals are the problem. But to transform one chemical to another chemical, that is also by the, and here the lipases in some proteases are very much promising. And as for it is possible to convert the economy into the green bioeconomy. That is a possibility. Only thing is I already given that there is the political will and social acceptance is very much important. And as a teacher, we should not interfere as far as political systems are concerned, but as far as the social, because we are nurturing to our students and we can clarify them how these particular things are important. And definitely the whatever green bioeconomy shifting, that is due to the various innovation as far as the biotechnology is concerned. So these are the already known products: bread, cheese, and oil. And majority of nations are generating a lot of dollars, and that the equal scope is there. So this is the story of another biotechnological products, Botox. You might aware that this 12 unit of Botox is required. Actually, the most powerful toxin on this earth is secreted by the Clostridium botulinum. From that, a Botox product is there. It is said that in order to kill all human beings, only the 1 cup poison is needed. 1 cup poison, if diluted and if given to the all population, they can die. Such a potent toxin is there. And later on, scientists find that they have some effect as far as our physiology is concerned. And so, this such kind of problem, facial problems of the sprinkling and all these things, this can be solved by this Botox. But currently, it is a very much costly one, henceforth used by the higher class of the society. But as I say that the development sustain part of inclusive part, we should be developing such a technology that it will be affordable to the all. So that is one of the challenge as far as biotechnology is concerned. These things are concerned. Not only to improve your beauty of face, but also in order to have a expression as far as actors are concerned. Suppose the typical kind of expressions are there. Also here, a systematic injection or appropriate dose might modify your faces and all these things. And such kind of acting expression are also controlled by indirectly by the microorganisms or the product by them. So they are already, I already given that they can manipulated, and manipulated organisms are also very much helpful. For example, insulin. Normally, we have to depend on the animal sources, but insulin, human growth hormone, interferon, beta cotton list is so many. But we will find that there are a much more less kind of industries are there as far as the genetic engineering is concerned. Only thing is that here we have to improve our research as far as the affordable technology is concerned, affordable methods of cultivation, and all these things. Then responsible consumption and production. So whatever we are consuming, whatever producing, we should take care of its appropriate utilization. And last year joined at Institute of Science, where the one building is there. It is remain as it is from the 25. One hall is there, and from 25 years nobody is going because some sort of radioactive elements are placed there, and at that time research is not there. And we have opened that thing, that particular hall, and lot of computers are there after 25 years, and we find that a lot of fungus are growing on the computer. I don't know what they actually eating and all these things. So totally all computers is embedded by the fungus. It might be chances that the building was leaky, water might be there, algae might grow and all these things, whatever thing is there, but they prefer to grow. So what is the thing that the microorganisms has a tremendous powers to degrade the various things. Only thing is that they have very slow because their rate is because plastic is just introduced just 50 years ago. Okay, and hence in part of evolution after thousands years, definitely microorganisms are going to degrade the plastics because they have such a strategy. Whatever things which is continuing, they are developing the strategy. They are improving their enzymes. They have their own mechanisms on this. Whatever we are producing, it should be produced. Many times we also have a solution that the searching a plastic degrading organism, searching a plastic degrading. So that is also not possible because why? Why the plastic is created? Why the plastic bag we require in order to protect it from the microorganisms? Okay. While their design is that they are protecting from the microorganism, then how they are degraded by the plastic? Then what happens? We can modify our strategy that we have to prepare a biomolecule, and from that biomolecule you have to prepare a bioplastic. That is referred as the bioplastic. What will the utility of that bioplastic? That bioplastic will be remain for the extended time periods. For example, 1 to 2 months, no microorganisms, they serve like plastic. But after 1 to 2 months, whenever they are going in environment, the microorganisms will easily get degrade them. So there are a lot of beautiful experiments are there. Total biopolymer plastics, they are synthesized from PHB, or several have embedded the amylase particles or the proteins particles, and then several have used the nanotechnology and all these things. But these problems are solvable, and in that also directions, a bioethics policy should be targeted. Bioremediation, pollutant, then the xenobiotic degradation, that is a possible. Then the climate action. I think already I have given that the microorganisms together, they are working for the welfare of the or maintaining the planet. Okay, here you will find that the bacteria are the primary decomposer. Whatever degraded, whether it in ocean or in terrestrial region, whatever thing is degraded, ultimate solution is the bacteria. Because one consume another, another consume another, and that one lot, whatever remains, so that is when it get died. That is utilized by the bacteria. And in true sense, they are the driving this planet. Okay. Here also you'll find they are the very nice, beautiful mechanism. All things are recycled. Whatever sustainable word I'm saying that the carbon is sustainably recycled, a phosphate is sustainably recycled, the water is sustainably recycled, the nitrogen is sustainably recycled, and in as far as all these elements recycling is concerned, actually in a true sense, microorganisms already playing a role. What we have to do? We have to identify them and have a promote them to execute a more function, or whatever excess of waste we are created, excess of the things we are created, for that purpose we have to utilize their. And actually no need to discover the technology also. So this is the already the ancient time adapted technology. Along with the earth, along with the evolution, this technology is adapted. Only thing is that we have to know the principles, and that same strategy have to develop, and how it could be work as far as the particular small portion is concerned, and that you have to. Here also, why microorganisms play a very important role here, I say that the this 20% carbon is associated with the plant cells. The plant cell wall protein, and the 20% carbon is associated with the bacteria. This is a microbial. That means total, I'm talking about the total carbon of this particular planet. Of this, 20% is the microbial, and the 80% is associated with the plant. But in case of nitrogen, 80% nitrogen and 80% phosphorus, both are present in the microorganism. Suppose whether this is the plant or whether it is animal, we have to go for the nitrogen or go for the phosphorus, because they are the ultimate consumers. They are accumulated, they are part of this. Already this relation is established due to the higher proportion, high biomass. And hence then you may ask that why, what about the animals? The animal biomass is a minor 0.1 of the total global biomass, hence not shown. That is very much negligible, hence not. Henceforth, the nitrogen and phosphorus are abundantly present with the microorganisms. Carbon is also there. Along with the plant, the microorganisms are very much important source. And for that purpose, here, this particular part, that is the climate action, is very much important. And without consideration of microorganisms, not possible to execute the any global effort as far as the maintenance or the sustainable planet dreams are concerned. conserving life in water and the life on the land. Already given that they are the directly, indirectly, even algae, blue-green algae are creating food in ocean. Then and then the fishes are survived. From that fishes, a large fish, and from large fishes, sharks are survived. And so, in order, suppose if shark is at the door of extinction, so what might be the reason it not getting its appropriate food? Why it not get there? Because of the ultimately the answer was that we have disturbed the microflora of the ocean, and hence just maintaining, don't take much more care of other animals, just try to maintain that whatever things we are adding that will not harmful to the microbes. Once the microbes are flourish in the life in the water on the in the land, automatically they will create such kind of things, and they will also support, not only establish themselves, but they support the life on water also and land also. There are so many examples are there where there is a role of 1 gram of soil contains many bacteria as the peoples on this earth. Soil bacteria promote the health of our crops, increasing the drought tolerance, protecting plants, disease, providing nutrients necessary. Attention to the microbial science can help to stop the land degradation and loss biodiversity. What is the definition of the barren field? Where it not support the plant, but actually it not support the. Suppose if you convert the, and at lab level also, suppose you want to make a particular land or water fertile, promoting plant, we can take a trial of the microorganisms. Microorganism can appropriately flourish. Definitely the plants can be flourishing there also, and hence microorganisms have direct role as far as the conservation of life in water and the land is concerned. Now we come to the conclusion part, and one very nice observation I came through. While having such kind of things, we'll find that there is a nature is itself a sustainable. The microorganisms are already a sustainable approach, but scientists, microbiologists, our should also have a sustainable approach as far as the various discoveries are concerned. Then and then, bioethics will be possible. How? One of the example is that the helicobacter, we all know that they are contributing for the peptic ulcer. This is a discovery in 1980s by Barry Marshall and Robin Warren. So they say that the helicobacter, there are ulcer, but at that time the cause is not known. There are some ulcers are there, and then later on find that these are caused by the excess growth of Helicobacter pylori. And what is the solution? The solution is that suppose if it is a bacteria, then we have to give the antibiotic. Antibiotic kill these things. And so Marshall discovery led to treating the peptic ulcer by the antibiotic. Once we have discovered that ulcers are correlated with the Helicobacter, then kill the Helicobacter pylori, and they are killed. Rate of H. pylori induced ulcer reduced by the 50%. When the antibiotics are given in 50% peoples, the peoples are not surviving with the Helicobacter pylori. But problem is that what happens, those which are survive, in that you will find the study of a 92% showed the weight gain the post antibiotic. Due to the excess of antibiotic, or those who are survived with the antibiotic treatment, or they recover from the ulcer, they have a problem. Means their ulcer problem gets solved, but another problem, obesity, will there, and they are gaining the weight. Then it is found that what happens, today it is known that the strains of H. pylori contains the CAG gene. This CAG gene produces the protein which have effect, which signals to stomach to decrease the flow of acid. Means our stomach's acid flow is depend on the protein which is secreted by the CAG gene, and CAG gene is present in the H. pylori. Now, as a biologist, we know that the genes are the different alleles, different allelomorphs are there, different morphological there. Means H. pylori, which is present in your strain, modified gene, then they have the different capacity to produce the protein, and that depending on that acid flow is there. And in whatever the strain is there, which is producing the higher, and so they are increasing the acid flow. If the acid flow, which acid is actually secreted by my body in accordance to the presence of the H. pylori, and depending on that ulcer is there. And henceforth, CAG-A provoke the or monitor the ulcer. Along with that, what happens? The CAG-A product that also produces another hormone, ghrelin. At that time, it is not. Okay, it is a hunger hormone. Means whenever I have taken a sufficient amount of diet, automatically that hunger hormone give the message that it's okay now, stop now. It's secreted. Okay. But what happens? Its production is dependent on the KAGE, and KAGE is present. Means H. pyrrole is controlling indirectly our ghrelin production. Okay. And in presence of H. pyrrole causes the postprandial decrease in ghrelin. If that is not appropriately produced, then what happens? Although I have taken a sufficient diet, but still a ghrelin is influencing not appropriate concentration. And so, despite of satisfying my particular things, I am consuming the food and I am gaining the weight. And hence, these things are correlated with this. To see Helicobacter pylori as a villain, that is the former picture. Okay. Of course, they are present, they are associated with ulcer. Science says that. But Helicobacter have also have positive effect as far as other things are concerned. And hence, as a scientist, as a microbiologist, we should also have a sustainable way to promote us. And that lot of details, lot of circuits which is associated with this are now known to us. And in accordance to that, we have to develop our systems and all these things. So that's all, my friend. Okay, here it is our decision to go in which direction. Excess use of antibiotics will goes to another thing, and sustaining the microbes will go to another thing. That's all. If any question is there, you can ask me.
Well, if there is any question, the topic is open for discussion.
Everybody is engaged in the dinner.
Good evening,
Yes,
sir.
please.
My
Participants
question
are
is,
requested to raise your queries.
May I ask the question?
Yes, ma'am. Suchita, ma'am, please go ahead.
Good evening, sir. As
Good
usual, very
evening.
nice, informative lecture in lucid way. I have a query. You talk about plastic degradation. It is not possible, you said, but lots of work is going on, and they interpret that actually degradation is there.
I not said not possible. Possible, but it is a very slow process.
Yes.
Okay. They have to fasten it, and for that purpose, what is the thing that the typical genetic system, whatever organism current have enzyme and all these things, they are adapted to take care of already. This plastic is totally new for it. Although the papers are there, but exact solution is not there. We can't collect all the plastics and just like a composting, we can solve the problem within within 1 year also not degraded. The plastic is degraded, but the rate is very much slow. So that I say.
चल 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 तेरे बाहर निकालूंगी चल 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 बोलेगा
Yes, anybody is there?
Good evening, sir. Thank you very much for very nice and informative lecture. Really, the thinking process has started. After your lecture, the thinking process has started. So there is no question, but I would really like to appreciate the way you have put that human beings are very new on this earth, and we are not even contributing into the biomass on the earth, and still we are trying to control the entire earth, the entire biosphere, but we should take the help of microorganisms who are really the kings of this earth. So thank you very much for this informative talk.
We are actually the true ancestors of the microorganism, because first life is Luca, last universal common ancestor. It is a microorganisms.
Yes.
Actually, the life is going it a very appropriate way Why it created human being and why human being created such a problems, I don't know. But God knows, evolution knows what might be the reason and all these things.
Yes, sir. It is really eye-opening. Thank you.
Here, I think in the research, I think rather than giving just weightage, we have to just try to know the how the nature is working, what is actually the happening. Your research also should be like that, in order to understand what actually happening, phenomena associated with that thing.
Right. True.
Many times we have patent and we have paper and we say, okay, that's okay, but how it clear your own concept, how that particular one organism which is growing throughout the year in a class, what it tells to you. So that feeling is also enjoyable story. Hence, be a part of research. And other outputs are definitely there. It gives the research paper, it gives the patents, it gives the promotion, all these things, but it gives the real happiness also.
Right. So if there is no any question, let's thank Dr. Ullas Patil sir for such a stimulating and informative talk. And you took us, sir, to our student days. It's long time we have listened to you, and it was really nice to see you. And the talk was, different, little bit different from the way you naturally talk on.
It
So
is also nice thing for me also because nowadays you also facing problems. Students are not attending the lecture, and I'm fortunate that although you become a teacher, but still you are attending my lecture, and that is a very appreciable point.
really, so it's really nice to see you after such a long time and to listen your lectures. Though it was in a virtual form, but still we enjoyed it a lot. Thank you very much, sir.
You cannot
And
miss your lecture, sir, always. Because every time there's a new addition in our knowledge.
certainly, sir.
Avinash Kale, sir, from Nashik.
Yeah, I know. Just yesterday we have interaction on WhatsApp,
Right.
and he is
Yes.
also in touch with us since by on the platform of Micro Olympiad, na?
Right.
Since
Yes. Right.
Yes, sir.
the sir's role is always a positive. He is promoting lot of students. Sir, actually, formally you are with a different college, no, in Satana.
Yes.
Or in KTHM college. You always get transferred.
Okay, but at Satana you were then at that time also there is.
At the time I was in Satana. Right now I'm in KTHM college.
Yeah.
Right.
He is from one of the college where the highest number of participants are there in microbiology.
Right.
Yes,
Right.
sir.
And we have a simple indicator that those which are from which college maximum participants are there. That means the teachers are dedicated working there. So that is one of the parameters. Now it is not possible because due to the NEP and all these things, lot of responsibilities are there. But at
Especially
that
because
time,
of that.
very nice to uh, interact with you, sir.
Thank you very much, sir, once again.
Thank you,
very
Ravi
much.
sir, Sandeep sir. Keep doing, organize such programs. I wish you all the best. And you have doing very important. And I am also aware that you are doing a lot of activities. Okay, 80% of the college works you are doing, and that is an appreciable thing. Uh, whether it is a NAC and all these things.
Sir, we
And
have
also,
a NAC visit on next the coming 15 and 16.
yeah.
And we are in the department only still 10 o'clock, 11
And
o'clock.
credit goes to all our colleagues also that they are also helping you and very nice uh, environment is there. I always miss, but still I'm not get detached from you. Wherever I come in Shirpur, you consider me as yourself, and
It's
that
your
is
legacy. It's your legacy only that we are taking forward.
very nice you are doing.
Sandeep is IQC coordinator there, sir.
Yes, Sandeep sir is handling NAC this time, sir.
IQC coordinator, handling all the NAC.
Sandeep sir is coordinator, and we should offer a best wishes to Ravi sir. Also, probably might be a next principal.
Let's hope so, sir.
So that will be ill wish, no sir. Okay, so we'll take your
Okay,
leave,
okay.
sir. Thank you very much
Thank you.
once
Thank
again.
you. Thank you all
Thank
of
you
you
and
once
good
again.
night.
Thank you.
Thank you, sir.
Thank you very much, sir. Thank you.
Thank you, sir.